Welcome to the first section of the course. In this section, you will start learning the very basics of the JavaScript language. So things like variables, data types, operators, if-else statements, and more. So in this part, we will not yet start building beautiful user interfaces. We will do that later, of course, but first we need to focus on the language fundamentals. And so these lectures are designed for you to learn these fundamentals and to give you an overview of the language before we actually dive deeper in later sections. Okay, so let's go start this journey right now. So let's now write our very first line of JavaScript code. And for now, we will do that in the browser developer tools. So just to get started as quick as possible. We will then switch to the code editor that we just installed before in the next video. So make sure to open up Google Chrome, and then there are three ways in which we can open up the Chrome developer tools. First, we can hit Command-Option-J on the keyboard, and that's on Mac. So on Windows, that's going to be Control-Alt-J. And so this will then open up this console that we see here. So all of these tabs here are basically the developer tools, but we are just interested in the console. Okay. Now another way of opening the developer tools is by right-clicking and then inspect, which will bring us here to the Elements tab. And then from there we can go to the console. And the third way, and I'm showing you all of them because I know that different people like to do it in different ways. So the third way is to come here to the Chrome menu, and then in there we go to View, Developer, and then JavaScript Console. Okay, and so we're back to the JavaScript console. And I'm increasing the font here a little bit by hitting Command+, and give it some more space. Now this JavaScript developer console allows us to write and test JavaScript code. So it's very useful during development, for example, to fix errors. Now we don't write real applications, of course, using this console, but now just to get started, let's use the console because it's a good and easy way to just write some JavaScript here. So let's write alert, which is a so-called JavaScript function, then open up parentheses and without a space between alert and the parentheses, and then we write a so-called string, so which is basically text, and let's write hello world. So that's the standard way of learning programming in any programming language. Then we write the closing parentheses, and then let's hit return or enter. And you see that JavaScript gave us this pop-up window here, which says hello world, just as we typed here in our string in our code. Great, so that's your very first line of JavaScript code right there. So any code that we write here and then hit return will immediately get evaluated. Okay, but of course we can do a lot more. So let's write some more JavaScript code, which of course you do not need to understand yet. I just want you to show some stuff that we can do. We will go into how everything works as we progress through this section, okay? So just to experiment a little bit, let's write a so-called variable. So let's say let JS equals amazing. And so once more, we are basically writing a string here, so text, and then we will do if and open parentheses JS is equal to amazing. Then we want an alert window, like we saw before, saying JavaScript is fun. And if I hit now return, we get this window which says JavaScript is fun. Okay? So again, I will explain all these concepts and how all of this works here as we go through this section. But for now, I hope that you can see the logic that we basically defined JS as being amazing, and then here in the next line, we said that if JS is equal to amazing, then JavaScript should show us this alert window with this text. Okay, and now we can also change JS to boring, hit return again, and now let's copy this text here again. So we want to run it again. So I'm just copying it and pasting it here. Okay, so let's try that again. And this time nothing happened. And so that's because JS is now no longer amazing. It is boring. And so in this case, if JavaScript is amazing is not actually true, right? Because it's boring now. And so in this case, the alert window is not shown. Now there's also another way of going to the previous command, which is by hitting the up arrow on the keyboard. So just like this. And so we can see all the previous commands that we used before. Great. Now another thing that we can do is to do simple math operations. Let's say just 40 plus 8 plus 23 minus 10, let's say. Hit return, and then here we get the result. So basically we can use this as a calculator. And I hope that you can see how useful this is going to become later down the road. Okay, and that's it for now. So I hope that this gave you a nice first taste of the language and of everything that is ahead. So if you want, you can experiment a little bit more with this, or you can move on right to the next lecture where we will learn what JavaScript actually is. So see you there. So you've already written a line or two of JavaScript. But what exactly is JavaScript? And what can we do with it? Well, that's exactly what we're going to find out in this video. And so in this lecture, we will set the stage for the rest of the course. And so it's really important that you follow this one until the end. So we can define JavaScript in many different ways. But my definition is that it's a high-level, object-oriented, multi-paradigm programming language. And with that being said, can we move on to the next lecture now? Well, probably not. Because what does any of that actually mean? So let's deconstruct this just a little bit to at least make some sense out of this. And starting with programming language itself, a programming language is basically just a tool that allows us to write code that will instruct a computer to do something. And of course, that's our main goal of using JavaScript, right? Then I go on and say that JavaScript is a high-level language, which means that we don't have to think about a lot of complex stuff, such as managing the computer's memory while it runs our program. So in JavaScript, there are a lot of so-called abstractions over all these small details that we don't want to worry about. And this makes the language a lot easier to write and to learn. Next, I say that JavaScript is object-oriented. And all that means is that the language is mostly based on the concept of objects for storing most kinds of data. And of course, we will learn all about object-oriented programming throughout this course. Finally, JavaScript is also a multi-paradigm language, meaning that it's so flexible and versatile that we can use all kinds of different programming styles, such as imperative and declarative programming. And these different styles are just different ways of structuring our code, basically. Again, you will learn all about this throughout the course. This is just the first, very high-level overview, but I hope it's been making sense so far. Anyway, now that we know what JavaScript actually is, at least kind of, what is the role that it plays in web development? Or in other words, what do we actually use it for? And to answer that question, let's actually look at the three core technologies of the web: HTML, CSS, and of course, JavaScript. So these three technologies all work together to create beautiful, interactive, and dynamic websites or web applications. Now, the HTML is responsible for the content of the page. So the text, the images, the buttons, and all the content that you see on a web page is always written in HTML. Then the CSS is responsible for the presentation of that content. So basically for styling and for laying out the elements on a web page. And then finally, JavaScript is the real programming language of the internet, and it allows developers to add dynamic and interactive effects to any web page. We also use it to manipulate the content or the CSS, load data from remote servers, and really build entire applications in the browser, which we then call web applications. Now we can also use the analogy of nouns, adjectives, and verbs to make this separation of roles a bit easier to understand. So in this analogy, HTML represents the nouns, for example, saying that the P element is a paragraph. And so paragraph is the noun here. The CSS then is the adjective because it describes the noun. Like this piece of CSS saying the paragraph text is red. And so here red is the adjective describing the noun. And finally, JavaScript is of course the verb, like saying hide the paragraph. And so here we are doing something, and so we have a verb. Okay? Does that make sense? Now, since we've been talking a lot about dynamic effects and web applications here, let's now actually take a look at a real example to make it even more clear what JavaScript is capable of. And so this is the Twitter web application on twitter.com. And there is a lot happening as we open a profile page like this one. And so I thought that this was a very cool example. So right off the bat, you see that there are these two rotating spinners on the page, meaning that JavaScript is probably loading some data from the Twitter service in the background. Then, as the data arrives, JavaScript hides these spinners and instead shows the loaded content. So this is a very cool example of manipulating styles and content, right? But there's also some simpler dynamic effects on this page, like JavaScript showing the tweet box whenever we hit the tweet button, and then hides it as we click outside of that box. And finally, JavaScript also displays this really nice user information as we hover our mouse over any user on Twitter. And it probably also loads this data on the fly. So a lot of cool stuff going on here, and it's all powered by JavaScript. How cool is that? And in fact, by the end of the course, you will actually know how to use all of these techniques that we just saw here. And so I hope that this makes you even more excited about all the content ahead. All right, now that we saw what JavaScript is really capable of, let's quickly recap and also look at other cool stuff that we can build with the power of JavaScript. So as you already know, JavaScript allows us to add dynamic effects to pages. And in fact, to build entire web applications in the browser. And these applications feel almost like the apps that we use on our computers and phones every single day. So we can say that JavaScript is what made modern web development and really the whole modern web itself possible in the first place. Now, if you're already somewhat familiar with the web development industry, you probably heard of modern JavaScript libraries and frameworks such as React, Angular, or Vue, right? And if you didn't, that's absolutely no problem. All you need to know is that these are basically tools that make writing modern, large-scale web applications a lot easier and faster. Now, what matters here is that all these frameworks and libraries are still 100% based on JavaScript. And what this means is that you should become really good at JavaScript before learning and using any of these frameworks, and not just jump into your first framework after you know how to write like 10 lines of JavaScript, okay? Also, your library of choice might not always be as popular as it is today. And the best way to be prepared is, you guessed it, becoming really good at JavaScript. Because then you can easily learn whatever is popular next. So no matter what anyone tells you, learning JavaScript properly is the single best investment that you can make in your web development career right now. Now, the JavaScript language and the web browser are actually two separate things. And what that means is that JavaScript can also run outside of web browsers. For example, it's possible to use JavaScript on a web server using a very popular technology called Node.js, which doesn't need any browser at all. And this allows us to create so-called back-end applications, which are simply applications that run on a web server and interact with databases and stuff like that. On the other hand, when we use JavaScript in the browser, we create so-called front-end applications. So in this course, we will learn the ins and outs of the JavaScript language itself, and of course also how to use it in the browser in order to create all these amazing effects that we've been talking about. So basically, we're going to be building front-end web applications. And in the future, I might also add a section about Node.js at the end of this course, so that you can get a sense of how we can use JavaScript outside of the browser environment as well. All right, and now just to finish, I want to mention that we can actually also use JavaScript to build kind of native mobile applications, as well as native desktop applications for any phone and computer operating system out there. That's because of modern tools like React Native, the Ionic framework, and tools like Electron. These have completely changed the whole development industry over the last couple of years, making things possible that were never possible before. So as you can see, there's almost nothing that you can't build after becoming really good at JavaScript, which, if you think about it, is really kind of mind-blowing. It's just amazing because the possibilities are so endless. Okay, and now to finish this lecture, I want to briefly talk about JavaScript releases, or versions as you might call them. We will come back to this topic by the end of the section because it's super important, but it's also a good idea to get a first overview of JavaScript releases at this point. Anyway, to make a long story short, there has been a huge update to the language in 2015, which is officially called ES 2015. But most people just call it ES6, simply because it was the release after ES5. And by the way, ES stands for ECMAScript. Now, after ES 2015, there is now a yearly new release with a couple new JavaScript features. In all of these new releases, or versions, starting from ES 2015, is what we call modern JavaScript. But why am I telling you all this? Well, it's simply because in this course, I'm going to teach you modern JavaScript right from the beginning. And I wanted to make that very clear right from the start. However, I'm also convinced that you need to understand what came before ES 2015, so ES5. And so I will also show you what's important of ES5. The reason for that is in a complete video about JavaScript releases at the end of this section. Because now I no longer want to bore you with theory. So instead, let's now finally get started. All right, now that we know what JavaScript actually is, let's now learn how to write code in a special JavaScript file and then how to run the code in the browser. Now, to get started with this section and with this course, you need to start by downloading the starter code from this GitHub repository that I created for this course. So this repository is at this URL here, which, in case you missed it, is at the very beginning of the course. So in the first text lecture of the first section. And in order to now actually download all of the starter code, all you need to do is to click on this green button here and then download zip. Okay? Now, by the time you're watching this video, GitHub, which is this website where developers basically host code, so later this website might look a little bit different, but just watch probably for a green button, which then says download zip. All right. Now, if you're on a smaller screen, or maybe on mobile, then this green button will actually not be visible here. So in that case, just scroll down a little bit here to the FAQ section, and then here you have this link. So you can also download all the code by simply clicking this link here. And by the way, since we're already here in the FAQs, please make sure to also read all of them before you actually move on in the course. So you will probably have one of these questions at some point, and so it's easier to then simply find the answer right here. Okay, but that's it here for GitHub. Now let's go ahead and extract all of this data that we just downloaded. And so here we go. So this is the starter code. And here you have basically one folder for each section or each project that we're building in the course. Then inside of each of these folders, you will always have one final folder and one starter folder. So you see that happens in all of these folders here. Now, the final folder is basically the final version of the code as it looks by the end of the section or by the end of the project. And so in case something goes wrong in your code while you're following the section, please then compare your code with the final code that is included for each of these sections. And that will then allow you to find and fix any mistake that you might have made in your code so that you can keep going in the section. But anyway, what we're most interested in the beginning is the starter code. So each of these folders has the starter code, and that's basically the starting point of each of these sections or projects. So let's now actually drag this folder here onto the desktop. And then I'm going to open it up here separately. And in my case here, since I'm actually the one writing the code first, it doesn't make a lot of sense to have these two folders here. So I will actually go ahead and take the index out, but you should not do that. So you should use this starter folder here as your project folder in VS Code. Okay, but again, I will now delete these two because I don't need them here to build this course, basically. But anyway, let's now open up a new VS Code window. So new window, and then here we click on open folder. And then we are already in the desktop. Let's just make the window a bit bigger here. And then I will select my project folder here. So in my case, that's going to be this folder. But again, you should now use that starter folder that's in here as your project folder. So I think that's the best way for you to approach this. So with that project folder selected, hit open. And then here we see the index.html file that we already had in our starter code. And this is an HTML file because usually JavaScript is attached to web pages, at least when we're building front-end applications, as we learned in the last video. So to start, we always need an HTML document like this, because our JavaScript needs to be attached to an HTML document. Now in HTML, there is a script tag where we can write JavaScript. So let's do that here in the head, right beneath this style. And if you're completely new to HTML and have no idea how it works, there is a very short crash course on HTML and CSS in section 5 of this course, I believe. So if you want, you can take that just to learn about the very basics of HTML and CSS in like 30 minutes or so. Anyway, let's now create this script tag here in which we will write our JavaScript now. Because in the first video, we wrote JavaScript in the console, remember? But that's not how real development works. So instead, of course, we write the code in files. So let's just write for now the same code that we wrote in the first video. So let JS equal amazing. And then in JavaScript, we usually add a semicolon to the end of each line. And this will then let JavaScript know that we are done with this line. And it's actually not really mandatory, and you will see some people omit the semicolons, but I still consider it a good coding practice, and I believe it makes the code a bit cleaner. So, just like before, we are then saying if JavaScript is amazing, then alert that JavaScript is fun. And once again, don't worry yet about how this code here works, okay? Just type it for now and just have a general idea of what it does. Now, to actually execute this code, so in this example, to show this alert window, all we have to do is to open up index.html in the browser, because again, this is where our JavaScript is now attached to, right? So let's do that. And so I'm going back to my desktop and then open this file with Google Chrome. And indeed, right away, we get this alert saying JavaScript is fun. And so that is coming from our index.html. We can click OK, and then it finishes. And we see our starter file, which is actually this text. So if you see in VS Code, JavaScript Fundamentals Part 1 in this H1 tag is exactly what we see here. And so we opened up the right page, and also our JavaScript is working. So if we reload this page now, we should see that alert window again. And indeed, here it is. Okay, let's push this to the side here. Here's the code from our previous lecture, VS Code, and push it to the other side. Okay, we can then get rid of this sidebar here that we don't need by hitting Command or Control B, or by clicking this file icon. And with this, we have enough space to see the editor and the browser here on the other side. So let me show you something very important now, which is how to see results from our code back in the browser. So let's take this math operations that we did in the previous lecture. So that was 40 plus 8 plus 23 minus 10. Let's give it a save. And you see that JavaScript actually automatically formatted this code. And I will show you later how you can set that up for yourself. Anyway, if we now reload this page here, where do you think this result will appear? So clearly it's not in this alert, and it's also nowhere on this page, because we didn't tell JavaScript to put it on the page. So let's open up the inspector here, and I will do inspect, and then the console, and then again increase the text, command plus, plus, and plus again. And you see that the result is also not in the console. So why is that? Why is this result not in the console like it was before? Well, it's because the console is just an environment that was built to execute small pieces of code and then show results immediately. So just like we did in the previous lecture. But it doesn't show results of our operations in code by default. Now, if we still want to display results, for example, from a calculation like this here in the console, we need to tell JavaScript to explicitly output that result to the console. And we can do that using a special function called console.log. Okay? And then if we take this code here and copy and paste it, and then save it, and then reload, then we need to click OK so that JavaScript can move on to the next line. And then we actually get the result printed to the console here. And it actually says that it's coming from index.html at line 31. And so that's exactly the line where we did do this computation. Okay, but let's recap here, because I know that this is confusing for many beginners. So in the last lecture, we were already in the console. And so then there was no need for using console.log. We also needed no script tag when we were in the console, right? But now we are actually in a script and no longer in the console. And so now we need to explicitly say console.log whenever we want to access the developer console like we did here. Okay? So basically, this is like building a bridge between our script here and the developer console on the other side that lives in the browser. And now to finish this lecture, let's actually take this JavaScript code out of the HTML file and put it into its own separate JavaScript file. So what we have right now, this script here, is called an inline script. And the only advantage of an inline script is that we don't have to load another file. But on the other hand, it's pretty bad for separating the website content from the JavaScript logic. And so usually we use external JavaScript files, as I just mentioned. Okay, so let's come back to the sidebar here and create a new file, which I'm going to call script.js. And that's a pretty standard name for a JavaScript script. Okay, so let's take that back. Come here, copy this code, and paste it here. And then once more, VS Code actually formatted the code here nicely. If it didn't on your computer, then just do that manually, and I will show you later how to set that up. Okay, and now we can get rid of this script here. Great, now we have a better separation of concerns between presentation and logic, and this also makes it easier to maintain code in the long run. All there is to do now is to link this JavaScript file to the HTML file, because right now our HTML has no way of knowing where the code is actually located. So if we execute this code by reloading the browser, now nothing will happen. Again, because this HTML file right now does not know where to find the JavaScript code. So let's do that connection, and we usually do that at the end of the body tag, okay? And actually we will use script again. All right, but now this time we're not gonna put any code inside this script element, but instead we are gonna specify the source attribute. So here, all we need to do is to then specify the name of the script and the location. Now in this case, this script, so this script.js file is in the same folder as index.html. So all we have to do here is to just write the file name like this. We don't have to specify the entire path to the file. Okay, so if we save this now and reload, then you see that it's back to working. So we have this pop-up here again, and then our result of this computation. Now, if you didn't get the alert window or this output here, then that means that your script file is probably not correctly linked to the HTML file. So in that case, please make 100% sure that the script file is in the exact same folder as the HTML file. Also make sure that you correctly spelled script src, just as I have it here in my HTML. And finally, also make sure that you have no errors in your JavaScript code. So these are some common mistakes that I see people make, which then leads to their script not being correctly linked. Okay, but anyway, at this point, we no longer need index.html open here. And here we have only our code logic. The rest of the presentation is gone. And so this is much cleaner and much easier to work with. Great. So now you know how to link a JavaScript file to an HTML file and then how to run it all in the browser. And that means that you're now finally able to really start learning the JavaScript language. So see you in the next lecture where we're going to start doing just that. Welcome back. Let's now start to really learn the JavaScript language, starting with values and variables. And let's start by getting rid of some of the code that we have here. So this one here isn't doing anything. And let's also delete this one so that we don't get that annoying pop-up all the time. So in this section, I will be using persons as examples. For example, a person's name, a person's age, or a job. All right. But anyway, let's talk about values now. So a value is basically a piece of data. So it's the most fundamental unit of information that we have in programming. For example, this text, Jonas, is a value. All right, so this here is a value. And again, if we want to actually see this in the console, let's say console.log, and then open up the parentheses, and then close them here, and then the semicolons. So if I save and reload, then of course we get Jonas. Okay, and so Jonas here is the value. Or we can of course have different values. For example, here 23 is the value, right? And so now we see 23 in the console. And the same is true up here. So in this line of code, where the values are actually 40 and 8 and 23 and 10. So all these four are different values. And then these mathematical operators here join them together to form just one value. And that value is then 61. Okay? And so a value is basically the smallest unit of information that we have in JavaScript. Now, one extremely useful thing that we can do with values is to store them into variables. And so this way, we can reuse them over and over again. For example, we can say let, and then the name of the variable, and then assign a value like Jonas to this variable. Okay? And so what we did here is called declaring a variable. Okay? And so this will actually create a real variable in your computer's memory and will store this value inside of that variable. And actually, that is exactly what we did up here right in the beginning. So here we declared a variable called JS and assigned the value of amazing to that variable, right? And so now it hopefully makes sense to you what we did back then. So I like to imagine a variable like being a box. So in the real world, a box can hold some object, for example, a book, and we can then write a label on the box to describe what's in it. And then we can find the object later when we need it by using that label. And variables actually work in the exact same way. So here, basically, we have a box called first name. And into that box, we put the value of Jonas. And now if we want to use this value, all we have to do is to basically use this label, or in other words, this variable name. So first name in this case. And so let's use it actually. And for that, once again, I will use console.log. And you will see me using console.log throughout this entire course, actually. So whenever we need to output something from our code to the browser, we always use console.log like this. And so here, now, instead of passing a literal value like we did here and here and here, now we can pass in, so we can write here the variable name. So first name. Okay? And if I save it and reload it, let's see what happens. Indeed, we get Jonas. So from line number 8, and so that's right here. And that means that indeed our variable declaration up here worked. And if we now change this to Bob, let's say, then here we should get Bob, right? And indeed, now it's Bob. Let's put it back. And of course, we can now use this variable name many times. So let's just copy and paste this here a couple of times and give it a save. And so now we have it 3 times. And that means that whenever JavaScript sees this variable name here, it will basically replace it with the original value that we assigned to the variable. So again, that's Jonas. And this is extremely useful because now if I want to change the first name to something else, I only have to do it in one place. So just here. So let's change it here to Matilda. And if I save it now and reload, of course, it will change in all the 3 places. So this is one of the big advantages of variables. Without variables, I would now have to manually change the value everywhere to Matilda. But like this, everywhere where I reference this variable, it will automatically get changed to Matilda. So that's one of the most important things to keep in mind about variables. Great. And now that we know what a variable is, let's just very quickly talk about conventions and rules for naming variables, because we shouldn't just give random names to variables. So first, the way that I named this variable here is called camel case. Camel case means that whenever I have multiple words in a variable name, I write the first word with a lowercase and then all the next words with uppercase, like this. So if it was just first, we would write it like this. But if we had more than one word, like first name, person, then you see that all the subsequent words are written with this uppercase letter. And this is kind of a standard in the JavaScript world. But of course, there are other ways of naming variables. For example, we could write first name with an underscore like this. And this is very popular in other languages like Ruby. Or like this, okay? And you can use whatever you like most. Just keep in mind that it's kind of a standard in JavaScript to write variable names like this. So usually whenever you see other people's code, the variables will usually be written using the camel case notation. So that's kind of a convention of how to name variables in JavaScript, but there are also some actual hard rules in JavaScript about how we can name variables. For example, we cannot write something like this, like 3 years, and set it to the value of 3. So this is an illegal variable name, and VS Code actually warns us right away here. And again, that's because this variable name starts with a number. And if we tried to load this in JavaScript, we would get this error. So that's an invalid or unexpected token here. And it's important to actually start reading these error messages right from the beginning of the course. So we see that this is a so-called syntax error, which means that we did a mistake in writing our code. So that's a mistake in the code's syntax. And we can also see the line where the error occurred, so line 13, so that we can then go ahead and fix it. And notice how this error was shown in the console, even though we didn't use console.log in this case. Okay, so we don't need to use console.log for the console to show errors. All the errors that we make will always end up in the console, and also here with this, error icon. Now anyway, back to our naming conventions here. So we already learned that variable names cannot start with a number. And in fact, variable names can only contain numbers, letters, underscores, or the $sign. So for example, if we try to write Jonas and Matilda equals JM, we would once again get a syntax error, right? And this time it's telling us unexpected token end. And again, that's because this symbol here is illegal in variable names. They can only contain numbers, letters, underscores, or the $sign. So this here, for example, would be allowed. So if we reload now, we get no more errors here. Another error might occur when we try to name a variable using a reserved JavaScript keyword. For example, if we did this, so new, for example, set it to 27, then this would also not be allowed. So you see unexpected token new. And that's because new is a reserved keyword in JavaScript, as we will see a little bit later. And the same goes for something like function. So again, unexpected token here. If we wanted to fix that, we could, for example, start this variable name with an underscore or with the $sign. So that's the only two symbols that are allowed besides letters and numbers. Another variable name that's kind of reserved but still actually allowed to use is the word name. So we could do this, and it would actually work, but in some cases this creates some problems. Because again, this is kind of a reserved keyword, but it's still legal to use. But since it is a keyword, never call your variables just name. Okay, that's why I always call them first name like this. Let's actually get rid of this one because we already have first name up there. Now, another convention is that we should not start a variable name with an uppercase letter. So we should not do this. So let person Jonas. Now, again, it's a convention, so that's not illegal. It's just that we use this kind of variable names with an uppercase letter for a specific use case in JavaScript, which is object-oriented programming, as we will see later in the course. So for now, never do this, but instead, you should write it like this, with a lowercase letter starting. On the same note, variables that are all in uppercase are reserved for constants that we know will never change. For example, the number pi, which is like 3.1415 and so on and so forth. So we know that this number is never going to change, and so that's a constant, and for that we have a convention of writing it in all uppercase. And VS Code actually marks this variable name with a different color, because it knows about this convention that we use. Of course, you could also write it like this, but then this would be kind of weird actually. So if it's a real constant, write it in uppercase like this. So that's a pretty normal convention there in programming as a whole. Finally, to finish this lecture, let's talk about one final convention, which is to make sure that our variable names are descriptive. And that's very important to write cleaner code. So when you name your variables, it should be really easy to understand exactly what value the variable is holding, just by reading the name of the variable. And that's kind of what we did up here by calling this one first name. But let me show you another example. For example, let's say my first job, programmer, and then my current job, teacher. So this is much, much better than writing this. So job 1, programmer, and job 2, teacher. So which set of variables do you think is more descriptive? Is it these ones or these ones? And I hope that you agree with me that it's much easier to understand what programmer and teacher are in this case here by simply looking at the variable name. So we know that my first job was programmer and that my current job is teacher. While down here, well, we would simply know that these are two different jobs. We don't know anything about them. And so this approach up here is a lot better. So keep that in mind whenever you write your own variable names. And actually keep all of this in mind that we just talked about for naming your variables. Okay? So just to quickly recap what a variable actually is, it is basically a box into which we can store a value. So we give that box a name, which in this case here is first name, or in this case here, it's my first job, for example. And then into that box with that label, we can store a value, which in this case is this programmer string here. Then later in the code, we can reference that variable over and over again. For example, like this. My first job. And if I save this, then of course, here we see programmer. Once again, you probably saw my code changing here automatically from the single quotes to double quotes, but that is just my automatic formatting doing its work. And now if we wanted to change this here, let's say coder, then it would change across the entire program, and now we get coder here. And that's what variables are all about. They're one of the most important things of programming, and so make sure to really understand them before you move on. So in the last lecture, we talked about values and variables. Now, in every programming language, values can have different types, depending on the type of data that we want them to hold. And we already saw strings and numbers, but there are actually more data types. So let's now take a look at all the types that we have in JavaScript. And first of all, in JavaScript, every value is either an object, which looks something like this, or a primitive value. So a value is only a primitive when it's not an object. And we will learn all about objects later, but for now, let's really focus on primitive data types. So there are 7 primitive data types: number, string, boolean, undefined, null, symbol, and big int. So let's look at them one by one. First, we have the number data type. And numbers are always so-called floating point numbers, which means that they always have decimals, even if we don't see them or don't define them. For example, the 23 value that we have here is exactly like having 23.0, but they are both simply the number data type. In many other programming languages, you will find different data types for integers and for decimals, but not in JavaScript. All numbers are simply of the type number. Okay? Next up, we have strings, which are simply a sequence of characters. And so they are just used for text, as we already learned. And always put them in quotes, no matter if double quotes or single quotes. Otherwise, JavaScript will actually confuse them with variable names. The Boolean data type is essentially a logical type that can only take one of the logical values true or false. In other words, a Boolean is always either true or false. Alright? We use Boolean values to take decisions with code, as we will see later. And these are the 3 most important data types that we will deal with the most. But there are still 4 more, which might be a bit more confusing. So first, undefined is the value taken by a variable that is not yet defined. And the variable that's not yet defined is simply just a variable that we declared, but without assigning a value. For example, like this children variable here. So basically, we can say that undefined means empty value. Then there's also null, which is actually pretty similar because it also means empty value, but it's used in different circumstances. But for now, don't worry about the details. I just want you to know that null also exists for now, okay? Anyway, next we have symbol, which was introduced in ES 2015. And this data type is not really useful for us. It simply defines a value that is unique and cannot be changed. And we will talk about this briefly by the end of the course. Finally, starting in ES 2020, there is also big int, which is for integers that are too large to be represented by the number type. So basically, it's another type for numbers, and we will talk about this one in another section. So these are the 7 primitive data types in JavaScript. But there is another fundamental thing to know about types, which is the fact that JavaScript has a feature called dynamic typing. This means that when you create a new variable, you do not have to manually define the data type of the value that it contains. In many other programming languages, you actually have to do that, but not in JavaScript. Instead, JavaScript automatically determines the data type of a value when it's stored into a variable. And this distinction between value and variable is pretty important, because in JavaScript, it's the value that has a type, not the variable. So variables simply store values that have a type. Many people don't know about this detail or just don't care, but this is how it actually works. Now, another important implication of dynamic typing is that later in our code, we can assign a new value with a different data type to the same variable without a problem. For example, variable x can initially be a number and then later a string. That's not a problem at all. And this can of course be very useful, but it can also be the source of some difficult to find bugs, which means errors in our code. Alright, so let's now actually see these things in action. But before we talk about data types, let's quickly talk about code commenting. So in programming, we use comments to literally comment code or to deactivate code without deleting it. For example, here, I could write a single line comment using // and then I can describe what this code is doing. For example, here I can say variable name conventions. And JavaScript will completely ignore anything that is a comment. So anything that comes after // like this. Okay? And this can be really useful to kind of divide our code into different sections and to explain what different pieces of code are actually doing in our code. So that's a very useful application of comments, but another one is to simply comment out code that we don't want to be executed for some reason. For example, let's say we don't want this code here to be executed, but we also don't want to delete it. So we can simply comment it out like this. And so if I save it, and then when I reload, this 61 should be gone. So you see, that's because JavaScript is now ignoring this code. It's just a comment. But since we didn't delete it, we can of course bring it back. So we can just delete it, and then it's back to normal. Now in VS Code, we can also automatically create comments using the command / shortcut. So that's command or control / to turn on and then again to turn off. So that's single line comments, but we can go even further and also create multi-line comments. And to do that, we do it like this. We start a multi-line comment using / and then asterisk, and then we end it with the asterisk or star and then the /. And whatever comes here is then normal code. Okay? And with this, I effectively got rid of this first code that we typed in the first lecture, but without deleting it. And so I can keep it here basically as a reference. All right? And so that's what I'm going to do in every lecture now. I will always kind of get rid of the previous code by using a multi-line comment like this. But now let's get back to the topic of this lecture, which is data types. So in the previous lecture, we already saw numbers and strings, right? So here we have a value, which is a number, and here we have a value, which is a string. So nothing new, right? That's what we learned at the beginning of the video. But we also talked about booleans, right? And so a boolean is a value that can only be true or false. And so if I write true, that is then automatically a boolean value, which is in this case true. Okay? And actually I can also log that to the console. And then here you get true. And you can see that it's not a string because strings are printed in white, and this value is printed in this pink. And so it's actually really a Boolean value. And of course, we can also store Booleans in variables. So let's say JavaScript is fun using the camel case notation that we learned about before, and then set it to true. And now we can log JavaScript is fun instead. But of course, the variable declaration here needs to happen before the log. And that's because JavaScript programs are executed from top to bottom like this. And more about that a bit later. Okay? What matters is that this needs to be at the end. So let's cut it and put it here. And also get rid of this one, save it. And here we still get true. And so here we created a nice and descriptive variable name holding a Boolean value. And remember that it's actually the value that holds the data type and not the variable, because I could now actually go ahead and change this to a value with another type. And actually I will do that in a second, but for now let's take a look at a special operator called typeOf. So typeOf is an operator just like the plus or the minus operator that we can use to show the type of a value. So let me show you how. So again, we use console.log because we actually want to see the result of this operator in the console. So typeOf, and then let's say just true. Okay? And more about how operators actually work and what they are a bit later in this section. For now, let's just see what happens when we reload this. And we see that it's a Boolean. So just as I said, the result of using this operator here on a value will be a new value, which is a string with the type of this value here. Okay? So let's do that again here. I will copy it just a couple of times. Just like this to make it a bit faster. And so here, let's use JavaScript is fun. And so this should also be a Boolean, but just to make sure. Here, let's now use a number and finally a string. So just to prove you that these are actually numbers and strings. All right. And indeed, we see that JavaScript is fun is a Boolean, 23 is a number, and Jonas is a string. And speaking about strings, I just want to quickly emphasize that we really always need to use quotes in order to create a string. Okay, let's actually show that here in the console. So we can use double quotes or single quotes, but we really do need quotes in order to create a string. So Jonas, for example, is a string. Okay, and so is Jonas with single quotes. But if we do it like this, then it's not going to work. So it needs to be the same at the beginning and the end. But without any quotes at all, JavaScript will see this as a variable. And so then we get this reference error, which is saying that Jonas is not defined. And that's because it's looking for a variable that does not exist. We never declared a variable called Jonas, right? And so that's why we get this error here. So when you need a string, don't forget the quotes. This is a mistake that I see beginners make all the time, and so really be careful about that. Now, moving on, let's actually see dynamic typing in action. And remember that dynamic typing simply means that we can easily change the type of a value that is held by a variable. So that sounds a bit fancy, but it's really as simple as this. So we already have a variable called JavaScript is fun. And so let's now reassign that variable. So we do that like this. So we write the name of the variable, then equal, and then a new value. And what matters is that we do not write the let here again. So this let keyword. So the first time that we declare a new variable, we need to do it using let. But then when we want to change the value of the variable, we simply write it again like this, but without the let. So we simply assign a new value here to this already existing variable. And this is actually the first time that we did that. And so it's important to understand what happened here. Okay. So again, we first declared a new variable with this name and assigned it this true value. And then down here, we changed the value that is in the variable. So using the box analogy from before, it's like initially putting a book in a box and then later taking the book out of the box and instead putting a phone in the box. And so just like here, we changed the content of the box. In our example here, we changed from true to the string of yes. Okay, and now let's just grab this piece of code here. so that we can see that dynamic typing actually works. So if I reload now, then let's see, well, we get here from line 34. Let's actually simplify this here a little bit. So commenting out this code, and I'm using command or control slash. Let's reload again. And so you see that initially the type of JavaScript is fun is a Boolean, right? But then we change it to a string down here. And so indeed, when we then test the type of the variable again in line 39, then we get the result of a string. All right? And that basically is dynamic typing. Great. And now let's see an example of undefined. So remember that number, string, and Boolean are the most used data types. But there are more, like undefined and null, and also symbol and big int. But in this lecture, I'm only going to talk about the three most important ones, and then also undefined and null. So remember that undefined is the value taken by a variable that is not yet defined. So basically undefined means an empty value. So it's perfectly legal in JavaScript to do this. So to define a variable without a value. And if we now take a look at this variable, then we should see undefined. And actually, let's also check the type so that I can show you something. Year. Okay. And so you get both undefined. What this means is that whenever we declare an empty variable, the value of the variable will be undefined and the type of the variable is also undefined. Now that maybe sounds a bit confusing, but it's really not. So simply put, undefined is both the value and the type of the value. And undefined is different than other types in this way. But this detail is not really important. What matters is that when you declare an empty variable like this, it will automatically hold the value of undefined. And that's why we get undefined here. Then, just like before, we can also reassign this variable basically. So we can now go ahead and say year 1991. And once more, without the let, because we are not creating a new variable. We are simply assigning a new value to year. So it used to be undefined, right? As we just discussed. And now I'm changing it to 1991. And so if I test for the type now again, it should now be a number, right? So let's check that. And indeed, we can again see the effect of dynamic typing. Great. And now finally, just to quickly finish, I want to show you an error that exists in the typeof operator. So all I'm going to do here is to quickly say console.log typeof null. So remember that null is just another data type and it's similar to undefined. And it's also similar in the fact that both the value and the type of the value are null. Okay? Now about this bug, JavaScript says that the type of null is an object. And this doesn't make any sense at all. And so this is regarded as a bug or an error in JavaScript. However, this bug is never corrected for legacy reasons. But null is of course not an object. This should return null just as type of undefined returns undefined. So just keep that in mind when working with typeof, but we will also come back to this later in the course to make sure that you don't create any accidental bugs because of this weird behavior. Okay, and that's all I had to tell you about data types in JavaScript. Let's now take a look at the three different ways of declaring variables in JavaScript. So up until this point, we have always used the let keyword to declare variables. However, there are also const and var. Now, let and const were introduced in ES6, And so they are modern JavaScript, while the var keyword is the old way of declaring variables. So let's learn how they are different and which one to use in which situations. And let's again start by getting rid of this code. Actually, all I will do is move this to the end. And in the future, I will just do this before recording the next video. So anyway, we use the let keyword to declare variables that can change later. So basically during the execution of our program. And that's exactly what we did here. So we used let to declare JavaScript is fun, and then we changed that later from true to yes. Right? For example, or another example I would say is, let's set the age to 30 at one point of the program, and then in another point of the program, we can change it to something else. For example, when the person turns 31. And then the age, of course, changes from 30 to 31. And so it's perfectly okay to declare a variable with let at one point in the program and then later assign a new value to it. In technical terms, we call this reassigning a value to a variable, or also we say that we mutate the age variable in this case. So it was 30 and now it's 31. And so we mutated the variable. Okay, so that's a term that you will hear all the time in the JavaScript world. So when we need to mutate a variable, that's the perfect use case for using let. And that also counts for the case that we want to declare empty variables. So for example, as we did here, where we declared an empty year and then later reassigned that variable to 1991. And sometimes we actually do this in practice. For example, when we want to declare all the variables at the top of a file, but only assign actual values to them later in the program, for example, based on some condition. Now, on the other hand, we use the const keyword to declare variables that are not supposed to change at any point in the future. So the value in a const variable cannot be changed. For example, let's say the birth year. 1991, for example. If we then tried to reassign that, let's say to 1990, it should not work. So let's test that. And indeed, we get a type error. So assignment to constant variable. And so that's exactly what the const keyword does. It creates a variable that we cannot reassign, or in technical terms, an immutable variable. So a variable that cannot be mutated. Okay? And the birth year is a perfect example for that, because in fact, the birth year of a person can never change, while the age, of course, can change. And so that's why we used let for the age and const for the birth year. Okay? That makes sense? Now, the fact that variables created with const are immutable also means that we cannot declare empty const variables. For example, this is not legal. So let's comment out this one here, again with command or control slash, so that it doesn't get in our way here. And then reload. And then we get an error, missing initializer in const declaration. And so this error message means that when using const, we need basically an initial value. All right, so just like here. Now, with these two different ways of declaring variables, you will probably ask, should I use let or should I use const to declare a new variable? Well, as a best practice for writing clean code, I always recommend to use const by default and let only when you are really sure that the variable needs to change at some point in the future. For example, when you have a variable that's really never supposed to change, like this birth year, you should always use const. Also, if you are sure that the age variable is never changing inside your program, you should declare it using const as well. The reason for this is that it's a good practice to have as little variable mutations or variable changes as possible, because changing variables introduces a potential to create bugs. So basically errors in your code. So again, by default, always just use const and let when you're sure that the value of the variable needs to change at some point in your code. And so from now on, I will probably use the const way of declaring variables as much as possible. Now, there's also a third way in JavaScript of declaring variables, which is the var keyword. But this one should actually be completely avoided, okay? However, we should still know how it works for legacy reasons, because you will see this maybe in older code bases or some older tutorials that you find online. So let's take a look at how it works. So var is basically the old way of defining variables prior to ES6. And at first sight, it works actually pretty much the same as let. So we can write var job equals programmer, and then just like with let, we can change the value of the variable later. Just like this. Let's take this one out and let's just reload. And we didn't get any errors, which means that it's basically allowed to mutate this job variable when we use var, right? Now, although it looks like var and let are very similar, below the surface they're actually pretty different. And actually there are also many differences between let, const, and var. So between all three of them. And you will learn all about these differences later in section 7, because this is actually really important stuff. And I know that I keep saying that you will learn some topics later in the course, but the truth is that learning is really not linear. It cannot happen in a linear way. So you sometimes need more advanced things right now, even without understanding them. But that's no problem, because you will understand them eventually. So right now, it would really not be useful for you to know that let is block scoped and that var is function scoped, right? Because you don't even know what a block or what a function really is. And so we will learn about these differences in section 7. For now, what matters is that you should basically never use var, okay? Now, just to finish, some people will probably point out that we actually don't even have to declare variables at all, because it's actually not mandatory. We can just write something like this. Last name equals Schmedtmann in my case. And then we can just use this variable name, in this case by logging it to the console, and JavaScript will happily execute this script even without us declaring the variable, right? We didn't use let, nor const, nor var in this case, but it still worked. However, this is actually a pretty terrible idea, because this doesn't create the variable in the current so-called scope. Instead, JavaScript will create a property on the global object. And once again, you will understand a little bit later what all of this means. But what matters is that you should always properly declare variables, okay? Never just write a variable like this without really declaring it. Great, you're doing great progress here, even though our code doesn't really do anything yet, and we're not really writing any real applications yet, right? But we still need to get some fundamentals down before we can do that. And so that's really important. And that's why I'm stressing all the little details about everything here. And I hope you see how important that is for your progress. Okay? And don't worry, we will get to the cool stuff even a bit later in this first section. Okay? But for now, in the next video, let's talk about operators in JavaScript. Let's now learn some more JavaScript fundamentals. And in this video, in particular, let's learn about some basic operators. And let's start by defining what an operator actually is. So an operator basically allows us to transform values or combine multiple values. and really do all kind of work with values. And there are many categories of operators, like mathematical operators, comparison operators, logical operators, assignment operators, and many more. So in this video, let's look at some of these types of operators, starting with mathematical or arithmetic operators. So we already used the plus and minus operators, but of course we can do all arithmetic operations. So we can also do multiplication, division, and many more. And let's use the minus operator to calculate ages based on a person's birth year. So let's say age Jonas equals, so the current year, and I will simply assume that right now it's 2037, so that's far in the future, but let's make this a bit fun. And then minus a birth year. So let's say 1991. Okay, and then let's just quickly log it to the console. So age Jonas, using the auto completion here. And so my age is 46, at least if we are currently in 2037. Okay. Now let's do the same for someone else. So let's say age Sarah. And notice how we're using nicely descriptive variable names here. So the age of Jonas and the age of Sarah, instead of, for example, saying age 1 and age 2. So again, right now it's 2037, and then let's say Sarah was born in 2018. So let's log her age to the console as well. And we could now write this same line as this. So again, console.log, but we can actually also log multiple values at the same time. So for that, we just write a comma like this, and then the second value. And we could do even more by adding more commas. So here we could then log something else. So give it a save. And so here we see now 46 and 19 years. Great. So that's how we used the minus operator to solve a very simple problem. In this case, simply to calculate an age. However, we can actually do better here. That's because we have this value here that is repeating itself. So this year, 2037, is appearing both here and here. And so that's not good because we are repeating this value. So if the year now changes, then we would have to change it in these both places. And we don't like that. And so that's why we have the concept of variables. So instead of having this value here, let's say now, and then we assign this value to the now variable. Okay? And notice how I'm always by default using const. Okay? And that's because I'm not changing any of these variables here anywhere in my code. Only if I needed to change them, I would switch to let. Okay, and now here I can replace this one with now and this one. And it should work the same, and it does. Great, so that's a very good use case for a variable right there. And of course, we can use all kinds of different math operations. So let's say console.log, and now we could go ahead and do age Jonas times 2, so using this asterisk or star, or we could also do age Jonas and divide it by 2, and notice how these are two different calculations here. So one calculation and another one, or basically another operation. And that's because, as I mentioned before, we can log different values at the same time in one console.log. So here we are creating one value, and here we are creating a second value. Let's actually divide it by 10. And then let's also use the exponentiation operator. So for example, 2 to the power of 3. Okay, and here we can use a comment to explain what this means. So that's a nice use case. So 3 means 2 to the power of 3, which is equal to 2 times 2 times 2. So 3 times this. So this should be 8, right? Let's try that. And indeed, 46, which is Jonas' age times 2, is 92. Then divided by 6 is 4.6. So that's this. And then 2 to the power of 3 is indeed 8. Nice. Next, there is another use case that we didn't use yet for the plus operator. And that's because we can use the plus operator to join strings, or in other words, to concatenate different strings. So let's create two variables. First name equals Jonas, and the last name equals Schmedtmann. And now I can concatenate these two strings using plus. So let's log that to the console. So first name plus last name. And let's see. And indeed, we have now one big string with both of the names together. So both of the strings that we declared earlier. But what if we wanted a space in between there? Well, that's not too hard. All we need to do is to create another string, which is just a space, and then concatenate it here with these two. And we can actually do that right here. So we want this string, first name, which is just Jonas. Remember, the JavaScript engine will simply replace this string with this one. Then we create an empty string, or actually a string with a space, and then we add that one to last name. So that's going to be Jonas plus a space plus Schmedtmann. Let's see. And indeed, that's exactly the result that we were after. Now there's actually a better way of doing this kind of concatenation of strings, which is called template strings. But let's focus on operators now. Okay, so this is a very useful one that we actually use quite often. So another type of operator is actually the type of operator, which we already used up here. So I'm not going to do that again. So remember, here we had the type of operator, and that would then give us the type of the value. So we already know how that one works. So let's move on to the next category, which are assignment operators. And the most straightforward assignment operator is just the equal sign. So let's say let x equal 10 plus 5. And so this equal sign here is actually itself an operator. All right. So in this line of code, we do actually have two operators. We have the plus and then the equal. Now in this case, x will be assigned 15 because the plus operator is executed before the assignment operator. Okay, and that's based on a couple of rules about operator precedence that I'm going to show you in the next video. So let me actually show that to you so that it indeed works, as I told you. And yeah, so it's 15. So 10 plus 5 is done first, and then the result of this operation, which is 15, will then be assigned to x. And so that itself is another operator. But there are more assignment operators. So let me show one to you, which is this one, x plus equal 10. So we know that at this point, after this line, x is 15, right? So let's write that as a comment. And then we have this next line. So this weird x plus equal. So what does plus equal actually mean? Well, let's write that again as a comment. So what this means is x equal x plus 10. So instead of having to write all of this, we can simply write x plus equal 10. All right, and so x should now be 25. because this x here from the previous step is 15. So here we are basically reassigning the x value. That's why I used a let here. So again, x at this point here will be 15, and then 15 plus 10 should be 25. And indeed, it's now 25. So let's write that result here so that we can keep track as I show you more operators. Because as you might imagine, there are more operators like this. For example, there is x and then times equal 4. And I hope you can imagine that this will mean x is equal x times 4. And this should be, in this case, 25 times 4, so 100. Let's check. And yes, it works. The same operator also exists with divided here, but I'm not going to go into that one. So to finish, I will just show you the x plus plus operator. And what this will do is x equals x plus 1. So let's see. And yes, we have 101. And we also have x minus minus. So if we do that twice now, what do you think will happen here? And indeed, we get 99. So minus minus is basically just the opposite of plus plus. So this one will decrease the value by 1, and so we end up with 99. Okay, so let's actually write that these are assignment operators, and these are, let's say, math operators. And so now let's talk about comparison operators. And these are pretty great. So basically we use comparison operators to produce Boolean values. So let me show you how that works, and then I'm sure it will make sense that the result of a comparison operator should be a Boolean. So let's say we are trying to figure out if H Jonas is greater than H Sarah, right? So what could the result of this be if we think about this logically? So H Jonas can either be greater than Sarah or not. And so if it is greater, then the result of this should be true. And if it's not, then it should just be false. So indeed, the result of this one is true. That's because Jonas' age is 46 and Sarah is 19. So this is basically like asking the operator, is the age of Jonas greater than the age of Sarah? And the operator will then essentially reply with yes, it is, which means true, or no, it's not, which means false. And this can be very useful later when we start taking decisions with our code based on conditions like this. Okay? Now, of course, there's also the less than, so the opposite, and also there is greater equal or less than equal. So basically we have this one, then we have this one, then we have greater equal and less than or equal. So let's see a nice application of the greater than equal operator. So let's say we wanted to test if Sarah is of full age. So that means that she must be at least 18 years old. And at least means that she is greater than 18 or exactly 18. And so we can use the appropriate operator for that. So greater or equal 18. Okay, so 18 should already be included, and that's why we have this equal here. So this should be true. And yes, it is. So if we make her 1 year younger, so let's say she was born in 2019, then her age is 18, as you see here, and she is still of full age. So it's still true here, and that's because we included 18 here in the range, basically by using this equal sign. But now if we made her born in 2020, she would be 17 And then this should turn out to be false. So let's check that. And yes, now it's false. Great. Now keep in mind that in real development, we would actually store these results here. So for example, the result of this comparison operator or this one here, we would store these results in variables and not just always log their results to the console, okay? But in this case, I just want you to show how all of this works. And so we need the console because really all we want to do is to see the results because we're still learning, okay? We could also just do all of this right here in the console immediately, but then we would kind of lose the record of what we're learning and it would be not so easy to scroll up and down, okay? But of course, we could just do this, right? We could just write age Sarah greater or equal 18 and we would still get the same result. And this works because the console actually has access to all the variables that is running in the current browser tab, right? So all the variables that we have here, like first name, for example, they are all right here. We can even auto-complete them, okay? But then again, if we would reload this page now, then all we just did would be lost. And of course, we could also simply, as I said, just store these results if we needed them later in our code. So is full age, and then we could do this. And so this variable would be the one holding the Boolean value then. And actually, as you see here in this pop-up, VS Code is so smart that it figures out automatically that this variable here is going to be a Boolean because of the code that we wrote here, which of course has a Boolean as a result. Okay, so now just to finish, let's say that we don't want the intermediate age variables and do this kind of comparison here all in one go. So this here. So let me show that to you in the code. So again, imagine we have a lot of code and we don't want to calculate these ages here separately. So we could just do now minus 1991 and then test if it's greater than now minus 2020. Or let's actually put it back to 2019 as we had before, or actually 2018, I think. So this now is basically just the same as this here. We simply are doing it now all in one step. So this code is the same as this, as it's highlighted here, and this is the same as this one. And so this whole line of code is essentially the same as doing this. Now the big question here is, how does JavaScript know if it should do the math first or if it should do the comparison first, right? Because we could think that the first thing to do is to calculate this, so basically 46, and then JavaScript could compare that 46 to now right away, right? That's what would happen if the operation would simply proceed from left to right. But we will see that it doesn't. So we will see that this actually works just fine, right? And so JavaScript has some way of knowing that it should first do this operation, then this one, so that it has the two numbers, and then only at the end, once it has the two ages, it will compare them with this operator in the middle. So how does that work? Well, that's what we're going to talk about right in the next video. In this lecture, we're going to talk about the precedence of different operators. So I already commented out the code from the last lecture, but let's actually bring some of it back here. And in particular, the calculation of these ages. So like this, and then also this code that we discussed by the end of the last video. Remember that? So the question that I asked by the end of the last video was why these two subtractions here, so this one and this one, are executed before this comparison operator. So basically the question is, why does this work? Okay, because we see that it does actually work. So this number here is clearly going to be higher than this one. Well, it works this way because JavaScript has a well-defined order of operator precedence. So basically the order in which operators are executed. And to actually see the precedence of all the different operators, let's check out a very handy precedence table. So let's Google MDN, which stands for Mozilla Developer Network, and then operator precedence. And so the one you're looking for is this one. So the one that starts with developer.mozilla.org. So MDN is a very well-known and widely used documentation site, and we will actually use MDN a lot throughout the course. And in one of the future sections, I will show you a bit better how to use this site. But for now, we're looking for a table that is here on this page, and it's this one. So here we can see that grouping using parentheses here has the highest precedence of 21, and then we have all the operators that we already saw. So here plus, minus, plus, plus, so they have a precedence of 17. Then we have a bunch of other stuff here that we don't know yet. But here is also typeof that we already do know. We have the exponentiation operator that I showed you. We have all these math operators here. We have our comparison operators, right? We have some other equality operators here and a bunch of other operators. And this is actually a nice reference where you can see all the operators that exist in JavaScript in one handy table. But let's now stay in the context of our current example, which is this one here, and let's understand what exactly happens here in terms of operator precedence. So we already know that these two calculations here are done before the comparison. And so let's actually see that in the table. So here we have the comparison, so this greater than, and you see that it has a lower precedence than the subtraction here. So this has 14 and this has 12, right? And of course, you don't need to know any of these precedence numbers. Okay, don't worry about that. It doesn't matter. No one knows these. You just have to have a general idea of which operators are executed first. So usually all the math operators are executed before the comparison operators, for example, because that makes sense. And so with this, we explain why this kind of comparison that we have here works. Now in this table, we can also see which operators are executed from left to right and which one from right to left. Like, for example, the exponentiation operator is executed from right to left, while most operators, especially the mathematical ones, are executed left to right. For example, let's say we wanted to calculate 25 minus 10 minus 5. And so this one should be 10, right? So let's check that. And indeed, we get 10. But if it was right to left, then it would be 5 minus 10 minus 25, which would then be something completely different. So this is an example of left to right operation, but assignment, for example, is a good example of right to left execution. So let's see where we actually have assignment here. So it should be one of the lowest ones, and indeed it is. So it's number 3. And so, as I said, this one is right to left. And so let me show you a nice example of why this is important. So let's declare two variables, let x and y, and here is something new. So we can define two variables at the same time, like this. So now in one line, we declared two empty values. So two values which are going to hold for now the value of undefined, right? So that's x and y. And now we can do this. We can say that x should be equal to y should be equal to 25 minus 10 minus 5, which we already know is 10. And so let's now log both of these values to the console. And what do you think will happen? You can really try to think about this before checking the result. And so what is it going to be? And actually, let's delete this one first. So to avoid some confusion there. And so we see that x and y are both 10. And so let's analyze why that happens. So when JavaScript first finds this line of code here to execute, it will look at all the operators that are present, and it will see the minus operators. And so it will start with these because they have a higher precedence. Right? So assignment has only 3, but where is it? Here it is. So the subtraction has a 14. And so of course it's going to be executed first and left to right. And so as we already know, this here will turn out to be 10. And so let's just write that here. So after these minus operations, we end up with this code basically. So x equals y equals 10, right? Because again, 10 is the result of doing these operations. And so now we only have 2 operators left, which are the equal operators. And so now they are executed. But as I showed you before, they are executed right to left. So from this side here, starting from the 10 to this side. And so what happens is that we will have y equals 10. And so at this point, y is equal to 10. And so what we have then is x equal to 10. Okay? And then after that, we're only left with x equal 10. And so at the end, both x and y are going to be 10. Okay, maybe that sounded a bit confusing, but that's just how it works when you evaluate from right to left. And actually, that's the way it has to be, because if it was the other way around, this wouldn't work. Just imagine if we had this assignment working from left to right. Then x would be equal to y. And y is undefined at this point, remember? Because we declared it here as an empty variable. And so again, if assignment would be from left to right, then first x would be equal to y, which would be undefined, and then y would be equal to 10. And so that's not the result that we expect here. And so once more, the way this works is actually very logical and makes a lot of sense. So I hope that made sense. And now to finish, let's just check out the one with the highest precedence, which is this grouping. So basically using parentheses. And that actually works just like in mathematics, where operations within parentheses are also executed first. So I hope you remember that from school. And a great example is to calculate the average of 2 values. So we have age Jonas and age Sarah. And so let's calculate the average age of these 2 people. So let's actually start by logging their ages to the console, just so we see. So age Jonas and age Sarah. And now I want to calculate the average. And actually, let's do that here above that. So let's say average age. And once more, don't forget the descriptive variable names. So average age describes exactly what this variable is going to hold. So to calculate an average, we need to add 2 values together and then divide them by 2. At least that's when we have just 2 values. So let's say age Jonas plus age Sarah. So that's the addition, and then divided by 2. But now what is going to happen? Well, according to our precedence table, we have the division here happening before the subtraction. So this is 15 and this is a 14. And so what happens first is age Sarah is going to be divided by 2, and then the age of Jonas is going to be added. So let's actually log that result here as well. And so here the average age is now 55.5, which really doesn't make any sense, because how can the average be larger than one of the 2 ages, right? And so that's where the parentheses come in. So by using parentheses, once more, just like in mathematics, we can make it so that this operation here is executed first. Okay, So basically everything that is within the parentheses which have the precedence of 21, right? So now this one is executed first and then the division. And so, yeah, now it makes sense. Okay, I hope that wasn't too confusing. And now you're actually ready for your first coding challenge. So I hope to see you soon in the next video for your first challenge. All right, I hope you managed to complete all the 3 points of this challenge. And so here is how I would have implemented it. So I'm starting with number 1, of course. And so let's say const mass mark equals 78. Okay, so that's just what is written here. And then height mark equals 169. And then the same for John. So mass John equals 92. And then height John equals 195. All right. And if you used different variable names, that's not a problem at all. As long as they are nicely descriptive, like these ones here, you're going to be fine. Also, you might have used let here instead of const, because you might assume that these are values that are susceptible to change, especially here the mass, right? However, I still decided to use const because I already know that I'm not going to change these values here throughout the program. And so just as we learned before, I prefer to always use const by default. And I advise you to actually do the same. Okay? Anyway, let's now calculate the actual BMIs. So const BMI mark equals mass mark divided, and let's check out the formula again, divided by the height squared. So that's going to be height mark squared. And then the BMI John, so that's mass John. And this time let's actually use the other formula. So this one here. So we're going to use height John times height John again. Okay, and now let's log both of them to the console here. So BMI mark and BMI John. And now we have an error here. Oh, of course, I missed the .log. Okay, try it again. And here we go. So we see that BMI mark is higher than John's BMI. Okay, so I hope you got the same numbers here than I did. And if not, I guess you should probably check your code, unless I have some mistake here. Let me check that actually. But I think everything is good. Okay, so if something is wrong, then please just let me know. All right. Now, if you implemented this in a different way, for example, you might not have created these separate variables here, then that's not a problem at all. Okay, you could have logged these calculations straight to the console. No problem at all. Again, what matters here is that you make this work and that in the end you get these same results here. Anyway, let's now also do step 3 and create a variable called mark higher BMI. So let's just grab this here and const. And so what we're trying to figure out is if the BMI of Mark is higher than the BMI of John, right? And so that's what comparison operators are for. Because remember that this one here will return either true or false. In our example, if BMI Mark is larger than the one of John, then the result of this whole operator here will be true. And otherwise, it's going to be false. Okay? So that's exactly what we did before in this example with the ages, if I remember correctly. So where's that? Ah, yeah, it's right here. In this case, it was the isFullAge variable, right? Okay. Anyway, let's log it here to the console as well. And so we expect this one to be true, right? Because Mark's BMI is 27 and John's is 24. And so Mark's is larger, and so the result of this should be true. So let's check that. And indeed, we get true. Nice. So we basically solved it. Now I just want to do the same here for test data too. So I will just copy this. So copy, and then I will simply comment out these first ones. So now I'm replacing these with 95, 188. And then here for John, we have 85 and 176. And the rest, of course, is the same. And that's the beauty of using variables, because now all we have to do is to change these values in one place, and then the changes will be propagated to the rest of the code here, which references these variables. Cool. So let's reload. And now BMI of John is 27, so it's larger than 26.8. It's actually very close, but still, BMI Mark is now lower than BMI John. So here we ask the question, basically, is BMI Mark larger than BMI John? And in this case, it's not, so it's false. And so that's exactly the result that we get here. All right, so this one is solved, and I hope you solved it as well. Again, it does not matter at all if you did it in a different way, as long as the results were the same. So basically, as long as you actually made it work. So hopefully that was a lot of fun and you could practice your skills a little bit, which is really something essential to learn programming properly. Without repetition and reinforcing your knowledge, it's impossible really to learn how to code. Anyway, see you now in the next video, where we're going to continue learning the fundamentals of the beautiful JavaScript language. Strings are a very important part of programming. And so let's now learn about an easy way to build strings using something called template literals. And let's start by creating some new variables here about a person, and in this case, about me, so that we can then concatenate them into one big string. And the birth year. Okay, and so let's now use these variables to build a string, something like, I'm Jonas, a 40 or 30-year-old teacher. So we're gonna then use this birth year to calculate the age, of course. So let's call that one simply Jonas. And as we already learned in one of the previous lectures, we can use the plus sign to concatenate strings. And so let's now start by doing that. So I want to write I'm, and here I'm seeing a problem. So when I want to use this single quote here for writing something like I'm or isn't, so basically when I need this symbol here, then I need to write the string itself using double quotes, okay? Because otherwise the single quote that I'm using here for I'm will finish the string. So I'm, and then I need a space, then the plus, and so here I'm saying I'm Jonas, and now I can actually use the single quotes. So what matters is that in each string, we start and finish with the same symbol, right? But both just create strings the same way. So right now we have I'm Jonas, comma, a, and now we want the age. So let's say a 30-year-old teacher. So we need another space here. And then let's actually calculate the age. So that's the current year. So let's put that here as well. And let's again say that the year is 2037. So plus year minus the birth year. Now, in order to make this work, we actually need to put this operation between parentheses. Like this. And so it will do the calculation first and then the concatenation. But you might be wondering, well, the result of this is going to be a number, right? But the rest of the things that we're adding here are strings. So how is this going to work? Well, this has to do with something called type coercion, which is something that we're going to talk about a little bit later in this section. But basically, JavaScript will simply convert this number to a string so that it can concatenate them, so that it can join them with the rest of the strings. So you will see that it's going to work just fine. Okay, years old. And then the job. And then we can finish with an exclamation mark or something like that. All right. And then let's also log this to the console so we can take a look at it. Okay. So I'm Jonas, a 46 years old teacher, and we're missing some spaces here. So that's around the years old. And you see that this is kind of a pain to manage these spaces and well, to keep track kind of how the sentence is structured. And so we will see a great solution to that in a second. So now it works, and yeah, just as expected. So as I was saying, for a complex string like this one, this can be kind of a pain. And so that's why, starting with ES6, we have a much better tool for doing this kind of stuff now, which is called template literals. So with template literals, we can write a string in a more normal way and then basically insert the variables directly into the string, and then they will simply be replaced. So basically, a template literal can assemble multiple pieces into one final string. So let me show you how that works. So let's call this one Jonas new. And now to write a template literal, we need to use backticks. So that's this symbol here. And on the English keyboard, you will find this one above the tab key. So again, we really need to use these backticks to tell JavaScript that we're writing a template string. The single quotes or the double quotes won't work for what we're going to do now. So now, as I said, we simply write a string and insert the variables in there. So I'm, and then we use the $, curly braces, and then the variable name. So I'm first name. And just to see if this actually works, let's log it to a console. So that's Jonas new. And indeed, I am Jonas. So you see that this is much easier because all we have is this one string, and then here we used this syntax to insert the first name variable. And now we can continue this, and it's going to be a lot easier. A, and then again a variable. Now in this case, we actually need a calculation, and that's no problem at all. We can basically write any JavaScript here inside of these curly braces. All right. Technically, we can write any expressions, but more about expressions in one of the later lectures. So year minus birth year, just as we did above. Year old, and then teacher. So no plus signs, no thinking where we should put the spaces like we did here. And so this is a lot easier. Let's reload. Oh, and indeed, there is a bug here. So of course, that's not teacher. That's actually the value of the variable job that we're interested in here. But once again, we found this bug because we simply read the error message. So get into this habit of always reading the error message to try to figure out where you are wrong. All right. And now, of course, it works. And I hope that you can see that this is a way easier way of writing this string. This really kind of assembles the string using the pieces that we give it. For example, this variable here, or this value that is produced by the minus operator. Great. So now you know how template strings work in JavaScript, and in particular in ES6. And actually, it's one of the most used ES6 features. It's really amazing and really useful in many situations. Now, I just wanted to let you know that we can actually also use backticks to write all strings. So strings where we do not insert any of these kind of placeholders here, like this. So we just demonstrate that to you. So we can use backticks for any regular string. So you see that it works here just the same. And many developers actually started using backticks for all strings, because then you don't have to think about which quotation marks you should use. You just use backticks always. And then in case you need to insert a variable, then it's much easier than to go back and switch out the regular quotes. So that's a choice that you can make. I actually don't do that myself, but I can see that it actually makes sense. All right. Now, another great use case of template literals is to create multi-line strings. So that's something that before template strings was a bit cumbersome to write. So let me just show that to you. So if you wanted a multi-line string before ES6, you would have to write string with, and then you needed this \n, which in many programming languages means new line. All right. So basically this is like a special character in programming, which in strings always means that a new line should be created. And then in JavaScript, we would need another \, like this, and then we could move to the next line and continue here. Multiple, let's create a new one, and then lines. And this actually only works because of a bug that's in the language. But let's see. So we get string with multiple lines. And you see that it's all the same string, but yeah, spread across multiple lines. But indeed, now with template strings, there is an easier way of doing this. So all we have to do is simply hit return, and it will create a new line for us. And this is actually going to be immensely useful later when we start building HTML from JavaScript. So by then, we will be able to use these backticks to create multi-line HTML elements to insert them onto a page dynamically. So that's going to be a lot of fun. Let's just see if this works. And indeed, it does. So whenever you need a multi-line string, you always make sure to use this template literal, because it's a lot cleaner. All right, and that's actually it about template literals. In the next lecture, we will finally start to make our code a lot more fun and take it to the next level by taking decisions. Welcome back. Let's now make coding even more fun and actually take decisions with our code to make it look a lot more real. So let's say that we want to write a program which checks whether a person is allowed to start taking a driver's license or not. And if she is, then it will print that to the console, and if not, it will print how many years are left until the person can start taking the driver's license. So let's start with an age, and let's set it to 19. So we have this age, and we already know how to check if this age is at least 18, which is the legal required age to start a driving license, at least here in Europe. So let's actually create a variable with that. And I think we actually already did that. Let's call this one is old enough. So again, with a variable name that describes exactly what we want here. So remember, to check if the age is at least 18, we need it to be greater or equal than 18. And so this will then include 18. So if the age is 18, the result of this operator here, or of this operation, will then be true. Only if the age is 17 or 16 or anything below, it will turn out to be false. Okay, so we have a Boolean value now, and we can use this to take decisions using an if statement. And the if statement works like this. All we have to do is write if, then open parentheses, and then in here goes a condition that is evaluated. And if this condition turns out to be true, then this block will be executed. So basically whatever code that we write into this block, which is denoted by these curly braces, will be executed whenever the condition that's here is true. So in this case, let's put the condition, and with condition I basically mean something that is a Boolean value. So let's use our isOldEnough variable here, because we already know that this will always be a Boolean. So again, whenever this value here is true, then the code that's in this block here will be executed. And if it's false, well, then it's not going to be executed. So let's log to the console. Sarah can start driving license. And let's just add a fun emoji here. And on the Mac, that's Command Control Space, and on Windows 10, the shortcut is Windows plus the period sign. But adding the emoji here is also not really important. So let's give it a save and try this out now. And indeed, we get Sarah can start her driving license. And that's because the age is 19, and so it's above 18. So this is true. And so if isOldEnough is true, then this block of code here will be executed, which in this case is just one line, but it could of course be multiple lines. So now let's put it to something else. So 15. And so now this is false. And so then this code block here should not be executed. So give it a save. Let's try. And indeed, we get no output this time. And so that means that it worked. So let's put it back to 19. And in practice, we always write this condition directly here. So let's do that. So what we want is just this part. So let's get rid of this. And so this is a lot more common. Let's actually get rid of this. And so we basically do this operation here. This will then return true or false. And depending on that, this code block will then be executed. And actually, let's put it back to 15, because now we can do something else, which is to actually add an else block. And we do that simply by writing else right after this first if block, and then we add another block. So what do you think this else block is for? Well, this else block will basically be executed whenever this condition here is false. So right now the age is below 18, and so this is false, and so as we already know, this block here will not be executed. Instead, the else block will be executed. So whatever code we have here. So let's write some code in here. And as I said in the beginning, we will calculate how many years are left for Sarah to start taking her license. So let's calculate that. Years left. And so that's simply 18 minus the age, right? And then we can log a nice string to the console which contains this variable. And as we learned in the last lecture, the best way of doing that is to use a template literal. So backticks, and then we say Sarah is too young. Wait another, and then we insert or placeholder here, basically. So years left, and then years. Okay. So the result of this should be 18 minus 15, which is 3. And so we should see wait another 3 years. So let's check that. And indeed, that's exactly what we got. And so again, since this condition here, so this operation basically turned out to be false, then this block of code was executed. Great. Just keep in mind that this else block is actually optional, right? So in the beginning, we didn't have this else block and it still did work. So when there is no else block, JavaScript will then simply move on to the next line after the if statement in case that the condition is false. Great. Now you know what an if-else statement is and how it works. And this is actually one of the most important things in programming. We take decisions with code all the time, which is essentially what we did here, so that we can execute certain parts of our program based on certain conditions. Okay? Now what we have here, this if-else statement, which is the official name of this kind of construction here, is called a control structure. So basically this structure here is called an if-else control structure. And it is called a control structure because this structure actually allows us to have more control over the way that our code is executed. For example, in this if-else statement, the whole code does not just execute in a linear way. So JavaScript does not execute all of this code here linearly. Instead, we can now control blocks of code that should execute and blocks that should not execute. And so again, that gives us a lot more control over how our code works, and that's why this is called a control structure. Okay, and there are other control structures that we're going to go into a bit later. All right, so I hope that you can see how this really takes our code to the next level. Now, just to make sure that you really understood this concept, let's create another very small and simple example here. And this time, let's actually create a variable conditionally and not just always use console.log. So let's create a birth year variable. I think we don't have it in this lecture yet. That's right. And so now what we want to do is to create a variable called century, which will basically contain the century in which this person was born. So in this case, it was the 20th century. But for example, if the person was born in let's say 2015, then it would be the 21st century. So to do that, we can of course write an if-else statement. So we can say if the birth year is below or equal to 2000, then let century equal 20. And so that then means the 20th century. And if not, then let century be 21. So we're assuming that the person is not born in the 19th century. So we're not accounting for something like this, for example. So instead, we always have the 20th or the 21st century. Now, to actually make this work, we need to define the century variable outside of the if or else blocks. We will go deeply into why that is, but for now, what you need to know is that this is because a variable that we define inside of any code block, which is what this here is. So this is a code block, and this is a code block. And any variable that we declare inside of one of these blocks will not be accessible outside of the block. So let me just show that to you very quickly. So if I try to read century now, then I will get an error here. You see, century is not defined. And so what we need to do is to define century outside and simply leave it empty. And then in here, we can then conditionally reassign it. Okay? And so now let's see how this works. And indeed, now we get the century 20. So 1998 is below 2000, and so this person was born in the 20th century. Now let's say 2012, and so that should now be 21st century. And indeed, that's exactly the result. So I hope that this example too made sense to you. Now, don't worry about the fact that we had to declare the century variable outside of the blocks. What matters here is that you understand the logic of the if-else statement. Okay, and I hope that was clear enough. But anyway, let's quickly recap. We can take decisions using code using the if-else statement. And for that, we write if, and then we open up parentheses, and in there we need a condition. And a condition is essentially any code that returns a true or a false value. And so this is a perfect example of that, because this operator here will return true or false, right? And so we can use this operator to create a condition, essentially. Then, if the condition is true, this block will be executed. So all the code that is in there, no matter how many lines of code there are. Now, if the condition turns out to be false, then this else block will be executed instead. So JavaScript will then skip this first block and go to the second block, which is this one. But the else block is actually optional. So if you don't have the else block, then simply no code will be executed. And this, in a nutshell, is how the if-else statement works. And remember that this is really powerful. So make sure that you really understand how this works. And when you do understand, then you can move on to the next video where there is a small challenge waiting for you. Again, I hope that you managed to do this. So let me show you how I did it. So let's start by getting this code from the other challenge. So coding challenge number 1, because of course we don't have to repeat the same code. So here we have the mass and the height of both John and Mark, and we already have their BMIs calculated. We also have this condition here basically already. So this operation here already tells us whether Mark has a higher BMI or not, right? So let's get rid of this. And so let's write our if-else statement. So if BMI Mark is greater than BMI John, and here we could have just used this variable, right? So we could have written Mark higher BMI right here. But as I said in the previous lecture, it's actually more common to write the condition directly in here. So let's get rid of this variable here. And then let's come here and get this string that we want to then log to the console. So console.log. And so this makes sense, right? So if BMI Mark is greater than BMI John, then we log to the console, Mark's BMI is higher than John's. And if not, then we use the else statement. So let's copy this one here. So in this case, John's BMI is higher than Mark's. And actually, let's log both of them to the console here first, just so we see if our if-else statement is working as expected. So BMI Mark and BMI John. And as you see here, the VS Code auto-completion is pretty smart. Give it a save. Let's try that. And we see John's BMI is higher than Mark's. So this one is Mark's, this one is John's, and indeed, John's BMI is higher. And so basically, this condition here turned out to be false, and the else block was executed. So let's try the same now with this first set of data here. And I'm commenting them out again using command/ or control/ on Windows. So I need to comment out this one. Okay, give it a save. And now we should see the opposite. And indeed, now Mark's BMI is higher than John's. So that is part 1, right? And now part 2 is to actually write a template string, or this should be called a template literal. We just fixed that. So we should use a template literal to include the actual BMI values. So like this here between parentheses. So let's do that. And so we're going to transform this to backticks. So that's the first thing. And then let's see the template again. Okay, so after the BMI, we include the parentheses. And then in the parentheses is where we want the actual value. And so this is where we put essentially the placeholder. So here we will put BMI mark. And here BMI John. Right, and now let's just copy this to make it a bit faster. Mark, and then here John. Okay, let's see. And yeah, that works just fine. Cool. So with this, we solved the challenge. And again, if you did it in a slightly different way, don't worry at all. That's completely normal, and it's actually a good thing. It means that you're basically finding your own style of coding, which is really a good thing. So don't worry about that. What matters is that you actually used an if-else statement. That was, of course, mandatory. Otherwise, you couldn't have make this work at all. All right. So this was a lot of fun because we actually made our code do something now. I hope you can really feel that as well. In this video, we need to go back to value types. So types are one of the fundamental aspects in programming. And converting between types is something that we do in every programming language. For example, converting a string to a number or a number into a Boolean is something that we do all the time. And so it's important that we learn about this before being able to move on further in the course. That's especially true for a language like JavaScript, which sometimes behaves in a weird way, as we will see in this video. Now, in JavaScript, there is type conversion and type coercion. So they sound very similar, but are different. So type conversion is when we manually convert from one type to another. On the other hand, type coercion is when JavaScript automatically converts types behind the scenes for us. So that's necessary in some situation, but it happens implicitly, completely hidden from us. Okay, so let's start with type conversion, which, remember, is when we explicitly want to convert from one type to another. So let's say that we have an input field on a web page for the user to input their birth year. And these inputs from input fields usually come as strings. So let's say that the input year that we get from the user interface is a string with the value 1991. But now, if we want to do some calculations with this, this won't really work. So let me show that to you. So console.log, let's say input year, and now plus 18. And so like this, we can calculate in what year the person will become of full age. Now, remember that when we have a string and add something to the string, it will basically concatenate the strings. So we can't expect that this actually adds 18 to this number here because it's a string. So let me show you what I mean with that. And so indeed, we now get a string which basically contains the 1991 string and then the 18 as well. Okay, so we need a way of fixing this, which means that we need a way of converting this string to a number. So let me actually log that here first. So console.log, and then the way we convert this string to a number is by using the built-in number function. So we write number, then parentheses, and then input year. And we will learn exactly what a function is and why it works this way in the next section. For now, just know that we can basically convert strings to numbers by using this function, which we execute using these parentheses here. So we have these parentheses inside these parentheses now, but don't get confused by that. So doing this operation here will then return the string as a number. So let me show that to you. And so indeed, now we get 1991 here in this pink color, basically. And the colors might change throughout the time. By the time I record this video, numbers are pink and strings are just this white. Let me actually print them both. And so that should make it really visible that, yeah, the first one is a number, the second one is a string. Okay. But now one thing that's really important to note here is that the original value is actually not converted. So the input year variable itself, so this one is still a string, right? It still holds the variable 1991 as a string and not as a number. That's why down here in this log, where we do this calculation, the result is still this string. Because again, the original input year variable is still a string. Using this number function will simply give to us a converted version. So if we want to perform this calculation, we need to use number here as well. And so this will now convert the number, and then to that number, the 18 will be added. And so now we should end up with something like 2009, I guess. And indeed, that's right. But now, what if we're trying to convert something to a number that is impossible to convert? Let's try that with a string that doesn't really contain a number. So let's try to console log converting to a number the string Jonas. So JavaScript will look at the string, will try to convert it to a number, but it won't really work. So what do we get instead? We get this nan, which stands for not a number. So JavaScript gives us this not a number value whenever an operation that involves numbers fails to produce a new number. So basically not a number actually means invalid number. It's not really not a number. And let me actually prove that to you. So we can check the type of NaN, so not a number. And as we will see, the weird result of this is that the type of not a number is actually number. And so again, not a number actually means an invalid number. It's still a number somehow, but it's an invalid one. And so again, we get not a number whenever an operation involving numbers fails to give us a new number. Okay, so that is converting strings to numbers, but of course we can also do the opposite. It's a little bit less important, I would say, but I still want to show it to you. So to do it the other way around, we use this string function, and that's quite straightforward, right? Just keep in mind that we need to really start it with a capital S, just like here the number function needs to start with a capital N. Otherwise, it's not going to work. So we get 23. And remember that whenever the value here is white, then it means it is a string. So it looks kind of the same. Let's again log both just to make this point. So the pink one is the value that actually has the number type, and this one has the string type. Okay, so again, this one is not as important, but I still wanted to mention it. Now, JavaScript can only convert to 3 types. So we can convert to a number, to a string, or to a Boolean. But we cannot, for example, convert something to undefined or to null. That doesn't make a lot of sense. Now here we only converted to numbers and to strings, but not to Booleans. And that's because Booleans behave in a special way. And for that reason, there is a separate lecture coming up on so-called truthy and falsy values. Great, so that is type conversion, where we do manually convert from one type to another. However, in practice, we rarely have to do it manually, because JavaScript actually does type coercion automatically for us in many situations. So let's talk about that now. And let's just separate it here with some comments. So type conversion, and then type coercion. So basically, type coercion happens whenever an operator is dealing with two values that have different types. So in that case, JavaScript will then, behind the scenes, convert one of the values to match the other value, so that in the end, the operation can be executed. And actually, we already saw that happening, if you think about this. So let me show that to you. Starting with strings, remember how we did this. I am, and then a number, let's say 23, and then another plus years old. So we already know that this is going to produce a string that says I am 23 years old. But how does that actually work? Because 23 is a number, so we have different types here, right? We have a string, a number, and another string. So let's check, and indeed that is what happens. And it works this way because of type coercion. So in JavaScript, the plus operator that we used here triggers a coercion to strings. And so whenever there is an operation between a string and a number, the number will be converted to a string. So thanks to type coercion, writing this would be exactly the same as writing this. Right? Because again, the plus operator will convert numbers to strings. And the same actually happens in template literals. It also takes all the number values and also converts them to strings. Now, if JavaScript did not have automatic type coercion, like many other languages don't, then we would have to manually do this like we just learned before. Then we would have to do string 23, and then this would be the only way that this would work. But luckily for us, JavaScript has type coercion, and so this will happen completely automatically behind the scenes. Now, actually, not all the operators do type coercion to string. So let me show you something else. So if we do 23 the string minus 10 the string minus 3, what do you think will happen now? So let's actually check. And it gives us 10. So what happened here? It looks like this time JavaScript converted the strings to numbers. And indeed, that's why we get 10. Because 23 minus 10 is 13, minus 3 is 10. And so what this means is that the minus operator actually triggers the opposite conversion. So in this case, strings are converted to numbers and not the other way around. So instead, if we use the plus, what do you think is going to happen? Then the 3 is converted to a string, and then the 3 strings are concatenated. Okay, so this is a very important distinction to keep in mind, because this actually confuses many JavaScript beginners when they don't know about this. So let's try another one here, and I'm again using 23 the string times 2 the string. And again, you will see that these values are going to be converted to numbers before. And indeed, that's why we get 46, because both of them are now converted to numbers, because that's the only way that the multiplier operator can work. And the same, of course, is true for dividing. Okay, so I hope that the distinction between type conversion and type coercion is now pretty clear. And now just to make sure that you actually got it, let's play a game called Guess the Output. So that's a game I just made up. So I want you to guess what happens here. So I'll write 1 plus 1 like this. And then we say n equals n minus 1 again. So what do you think n will look like when we log it to the console? So essentially we start with 1 the string, then we add 1, and then we subtract 1. So take a moment to think what this should look like, and then let's take a look at the solution. And it is 10. So that's a bit counterintuitive, but according to the rules that we just learned before, it actually makes sense. So here in the first line, 1 plus 1 will actually turn out to be 11 the string, because we have one string here, and then the plus operator will automatically convert the number to a string. And so the result of this one is the string 11. But then here we have the minus operator. And in the minus operator, whenever we have a string or more strings, it will then convert it to a number. And so here, the string 11 will be converted to 11 the number, and then 11 minus 1 is of course 10. Okay, let's do 1 or 2 more, and let's do it in the console here. And we can actually clear the console of all this clutter here by clicking on Clear Console. Okay, so let's do 2 plus 3 plus 4 plus 5 the string. And now you actually can't really guess because we can already see the solution there. Okay, so let's try to understand what happened here. So we start here with 2 plus 3, which makes 5. Then 5 plus 4 makes 9. And then we end up with 9 plus 5 the string. And then, as you already know, since we have a string, the plus operator will convert the other operand, which is 9, also to a string. And then we end up with 9, 5 as a string. Okay, and another one. 10 minus 4 minus 3. And keep in mind that these are strings. And then minus the real number 2. But then plus 5 the string. So again, this looks very weird, but the logic is kind of the same as before. So we have two values that are subtracted, and so JavaScript will convert them both to numbers. And so the result of this is 6. Then 6 minus 3 is 3. Then 3 minus 2 is 1. And then we end up with the same situation as before. So this 1 will be converted to a string, and then we end up with the string 15. Okay, and with that, I think this should be pretty clear now. And you might be wondering why we're talking so much about this, but it's really important that you know about this right from the start so that you can write your code with all of this in mind. Now, many people actually don't like type coercion and think that it's a bad practice to rely on type coercion. One reason for that is that type coercion can, in fact, introduce many unexpected bugs into our program. However, this only happens when we don't really know what we're doing. So when we don't know about the stuff that I just showed you. Because if you know, then it's way easier to avoid these errors. So in my opinion, coercion is actually a great mechanism that is going to allow us to write a lot less code and also to write more readable code. So really make sure to take some time to understand how type coercion works and then just embrace it in your code. So we talked about type conversion and coercion to numbers and to strings. But I didn't mention booleans yet, right? That's because we need to learn the concept of truthy and falsy values first. And so that's what we're going to do now. So let's get right into it. So falsy values are values that are not exactly false, but will become false when we try to convert them into a boolean. And in JavaScript, there are only 5 falsy values. And let me actually write them down here for you. So 5 falsy values. And they are 0, the empty string, undefined, null, and not a number. And that's it. Of course, false itself is already false. So we don't need to include it in the list of falsy values. So again, all of these 5 values will be converted to false when we attempt to convert them to a boolean. They're not exactly false initially, but they will become when converted to a Boolean. So that's the definition of falsy values. Everything else are so-called truthy values, so values that will be converted to true. For example, any number that is not 0 or any string that is not an empty string will be converted to true when we attempt to convert them to a Boolean. And so let's actually see that in practice. So just like with numbers and strings, we can use the Boolean function, Boolean, and then 0. And we know that this one is a falsy value, right? So let's copy this and do this a couple times for some different things. Let's do the same with undefined. Let's do it now with a string. And it's not an empty string. And now let's also do this with this empty object. And we will learn about objects in the next section. So this here is simply an empty object. So let's see what the result of this is going to be. And we see that indeed converting the 0 here to a Boolean resulted in false. And the same for undefined. It's also false. But then the string Jonas is true. And so that's why we say that any string that is not an empty string is a truthy value. And the same actually applies to this empty object here. It's also a truthy value. But if we tried to convert an empty string, well, I think then you can already know what the result will be. And it's going to be false. Again, because it's a falsy value, as we see up here in this list. So that's what truthy and falsy values are, and this is how we could convert them to Booleans. But in practice, I actually never did this in my life. I never used this function here in practice. This was just to show you the concept of truthy and falsy values. So in practice, the conversion to Boolean is always implicit, not explicit. Or in other words, is always type coercion that JavaScript does automatically behind the scenes. But when exactly does JavaScript do type coercion to Booleans? Well, it happens in two scenarios. First, when using logical operators, and second, in a logical context, like for example in the condition of an if-else statement. And we're going to talk about logical operators in a future lecture, so let's now go back to the if-else statement and see how type coercion works in the if-else condition. So, let's say that we have a money variable. And in the beginning, we don't have any money. So we set it to 0 here. And now we can use what we just learned to test if the person has currently any money or not. Right? So let me actually write it first, and then I'm going to explain to you how it works. So if money, then let's log to the console something like don't spend it all. And notice how I used the double quotes because in here I have a single quote for the don't. And then we can also do an else block. So for the case that the person does not have any money, then I can just say you should get a job. Okay, so let's see if this works, and then I'm going to explain to you why it works. So indeed, we got the you should get a job, and so that's the else part here, right? So this here is the code that got executed. But why? Well, we know that money is a number right now, and this number is 0. But in the logical context of an if-else statement condition, so that's right here in these parentheses, here JavaScript will try to coerce any value into a Boolean. So no matter what we put here, if it's not a Boolean, JavaScript will try to convert it to a Boolean. And that happens using the truthy and falsy value rules that we just discussed in the beginning. So we know that money here is 0, but 0 is a falsy value, right? And so in this logical environment here, in this condition, this number 0 will be converted to false, just like it happened here when we converted manually the 0 to a Boolean, right? So here this conversion to Boolean returned false. And here the exact same thing happens. Money is 0, and so 0 is converted to false because it's a falsy value. And as a result, the else block here is executed, and so on the console we see you should get a job. Now if we change this to something else, and it doesn't matter what number, let's say 100, then 100 is a truthy value. And so this means that this condition will be true. And so the if block will be executed. Wanna see? Yes, indeed. Now it says don't spend it all. Great, I hope that made sense. And we can test this in another situation to make really sure that you understand it. So another use case for these truthy and falsy values is to check if a variable is actually defined or not. And this might seem like a weird use case, but you will see later in the course that it actually makes a lot of sense sometimes to test if something actually exists or not. So let's define a variable here as height, and then we can simply do this. If height, then let's run this code. Yay, height is defined. But if not, well, then just say height is undefined. Okay, so let's see the result, and again I will explain you why it works this way. And maybe you can already guess why it works this way. So can you try to explain it to yourself maybe? That would be a good idea to make sure you actually got the concept. But anyway, we know that height is undefined in this moment, right? Because we didn't assign it any value yet. And we know from our little list here that undefined is a falsy value. And therefore, just like before in the money here, this height variable here in this logical context will automatically be converted to a Boolean. And since height is undefined and undefined is a falsy value, height right here will be false. Therefore, this block here will be executed. But now if we assign something to it, no matter what it is, then we will get the other result. So now it's true, and so now this block here is executed. However, with this, we can actually run into a problem. So let's say that the height is 0 for some reason, and that's a perfectly valid number. But watch what happens when we run this code. Now we get again, height is undefined. So, why is that? And I hope you know the answer by now. Well, it's because 0 is also a falsy value. And so this one will also trigger this else block. But in this case, that's actually not what we want. So this is kind of a bug. It's an error in our application. Because here in this if-else statement, we didn't account for this scenario. We only accounted for the scenario that the height is either defined or not. But we didn't think of the height being 0, right? And so right now we get height is undefined, even though that's not true. So this is just to illustrate an example that there can be problems using this approach. However, we can fix this using logical operators, which is going to be very interesting, and we will talk about that a little bit later in this section. But first, in the next lecture, we need to talk about equality operators. So stay tuned for that. So far, we have only used comparison operators to take decisions with if-else statements, right? But let's suppose we want to check if two values are actually equal, instead of one being greater or less than the other. And for that, we have different equality operators. So let's start again with an age variable and set it equal to 18. And I'm using age all the time because it's so easy to make simple calculations with it. So let's now create an if statement which will log to the console that the person just became an adult only if the age is exactly 18. So we can use an if statement, as we already know. And now to check if the age is exactly 18, we use the triple equal. Okay, and that's it. Let's now write the block of this if statement and then execute it, and then I will explain what happened here a little bit better. Now, whenever our if block only has one line, we actually don't need the curly braces. Okay, so we don't need to create this block if we only have one line. So we can omit this and only write this one line of code. In this case, you just became an adult. So let's test this. And indeed, the result is that we see this string locked to the console. And if the value would be something else, for example 19, then age is no longer equal to 18, and so we shouldn't see this result. And indeed. But let's put it back to 18. Okay, so how does this equality operator here actually work? Well, just like the comparison operators, this operator will return a true or a false value, so a Boolean value. Only that in this case, true will only be the result of this operator in case that both sides are exactly the same. All right, let's actually show that result to you. And actually we can do that right here in the console. So if I say 18 equal to 18, this will be true. But if I say 18 equal to 19, it will be false. And so that's exactly what we used here as a condition in this if block. So don't confuse the assignment, which is just the single equal, with the comparison operator, which is this triple equal. Now, besides this triple equal, we also have a double equal. So the difference is that this one here with the 3 equals is called the strict equality operator. It's strict because it does not perform type coercion, and so it only returns true when both values are exactly the same. On the other hand, there's also the loose equality operator, which is only 2 equals, and the loose equality operator actually does type coercion. So let's see that here in the console again. So in this case, I can do 18, the string, equal 18, the number, and it will still give me true. So again, the double equal does type coercion. So what this means is that this string here, this 18, will be converted to a number. And then the number 18 is the same as this number 18. Now, as I mentioned, the triple equal does not perform type coercion. And so let me show that to you. And so it's false, because 18 the string is of course different than 18 the number. So it's not the same, and JavaScript does not convert them for us. So let's try that also here in our code. And I'm just gonna copy this one. And then this. And let's say here loose and here strict. So if I run this now, both these conditions should be true. So 18 the number, which is the age right now, is equal to this 18 the number, right? It's strictly equal, but it's also loosely equal. So 18 the number is of course also loosely equal to this 18. So let's run that. And indeed, we get the strict and the loose string printed to the console. But now if we change this to 18 the string, well, what do you expect to happen then? And indeed, only this line of code here is executed. So this one which says loose here, as we see here. And so that's because of the result that I showed you earlier, which is that with the loose equality operator, 18 the string is the same as 18 the number, because 18 the string will be converted to 18 the number. So I hope that's not too confusing for you. It is actually quite a confusing topic in JavaScript, because this loose equality operator, so this one here, is full of really weird rules and behaviors. This means that if we use this one here, this can introduce many hard to find bugs into our code. So as a general rule for clean code, avoid the loose equality operator as much as you can. So when comparing values, always use strict equality with the 3 equal signs as I showed you here. And that's the reason why I showed you this one first. This is something that actually most JavaScript developers advise you to do. So it's a good rule for sure, even if we actually need type conversion. In that case, it's better to convert the value manually before the comparison than relying on the double equal operator. So always default to the triple equal operator and pretend that this one doesn't even exist. Okay, of course I still needed to show it to you, but from now on we will assume that it doesn't even exist. Great, so let's do another example here, because I actually have some more great stuff to show you. And the first thing that I want to show you is that there is a pretty simple way of getting a value from any web page. We can do that by using the prompt function. And again, we will learn what functions are in the next section, but this is how it works. So we just write prompt and then a string. And let's ask the user for his favorite number. So what's your favorite number? So let's see what happens when we load this now. So we get this prompt window. And here we can input something and then hit return. So basically all this here will create a value, in this case the number that I just inputted. But we need to store this value somewhere. So let's create a variable called favorite. And so it's in this favorite variable where the value that we put into that form will be stored. So let's take a look at that. Console.log favorite. So 23. And you see that it now logged the value. But it's printed here in white. So remember, that means that it is a string. Let me prove that to you by checking the type. So by now we know how to always check the type, right? It's pretty simple. And so now we should see string. Now, of course, we have to give the number again. So 23 is the result, and it is indeed a string. So now let's write some logic here to check if this is a great number, basically. So let's say if the favorite number is equal, and let's use this one first. So if the number is equal to 23, then let's log to the console. Cool. 23 is an amazing number. Okay? And so now this should actually work, shouldn't it? So 23, and we get this result. So again, why is that? Well, because we used the double equals here, which is the loose equality operator. And this one will do type coercion, right? So right now what we have here is basically 23, the string, which is this one here, equal 23. And so this one will be converted to a number, and then the number 23 is of course equal to 23. However, if we use the triple equals, so the strict operator, then it should not work. So 23 again, but we do not get that log. And by now you already understand why that is, right? So remember how I said that we should always use this one. And so we now have to convert this string to a number. And we can actually wrap all of this into that number function that we used to convert. So number, and then we put all of this here, which is the one that will generate the string 23, and then we wrap that into the parentheses to execute the number converter. And so right now, favorite is going to be a number, and so then this should be back to working, because then at this point we have 23 equal 23. And so that, of course, is true here, and so then this line of code will run. So 23, and indeed it does. And you see that it's also now pink, meaning that it's a number. And if I use something else, then of course this here is also false. So if I have 22 here, then this will of course be false because they are different. But this actually brings me to my next point, which is the next cool thing that I wanted to show you. And that is that we can actually add more condition to an if-else statement. So far we have only used if, else. However, we can also add an else if block. And that works like this. So else, and then a new if. So let's now do favorite equal to 7. And then let's say 7 is also a cool number. And so what this will do is to first check if the number is 23 here. Then if it's not, it will of course go to the next block, which is this one, and then it will check this condition. Well, if the number is 7 now, then run this code. And then at the end, we can also add an else block. So let's say number is not 23 or 7. So let's test that. So if I put 7 now, we get 7 is also a cool number. And so that's our else if block here. So this second one here running. But now if I do something else that is neither 23 nor 7, then we go to that last else block here. Okay, and we can actually keep adding more and more. So we can do this as long as we want. So we can do else if favorite triple equal 9, for example. Let's simply grab this one here. Say 9 is also a cool number. And then number is not 23 or 7 or 9, just to make it really complete. And so now if we use the 9, then 9 is also a cool number. So we now have a way of not going immediately into the else block once the initial condition is false. So if this one is false, it doesn't immediately go into the else block. There are now other conditions that can be checked one after the other. First, we check for 23, but if it's not 23, we check if it's 7. If it's not 7, we check if it's 9, and if it's not 9, well, then the final else block will be executed. Okay? I hope that makes sense. And we actually use this from time to time. Okay, and now to finish, there's also an operator for different. So we talked about equal, but of course, there must also be an operator which does the opposite. And so that's the different operator. And so let's now check if the favorite is different from 23. So we use the exclamation mark and then the double equal, which is the strict version. And then there's also the loose version, which is this one. So with just one equal. But just as before, always use the strict version. So if the number is not 23, we can log something like saying, why not the 23? Okay, let's try that. And let's use 9. So what do you think will happen when we use the number 9? So we get first this log here from this else if block, right? But then we also get this why not 23 message. And that's of course coming from this if block here. So 9 is of course different from 23. And so this code here is being executed. But now if we actually use the 23, then only this line of code is executed and this one here isn't, because the favorite number is now equal to 23. And so of course it doesn't make sense to then execute this one here. So sometimes we need the different operator and sometimes we need the equality operator. Just choose whatever you need to solve any particular problem. In both cases, just make sure to use the strict version of the operator. When we learn about if-else statements, comparison and equality operators, and Boolean values, we also need to learn about logic, and in particular about Boolean logic. So let's do that in this video. So basically, Boolean logic is a branch of computer science which uses true and false values to solve complex logical problems. And in order to do that, it uses several logical operators to combine true and false values. So much like we use arithmetic operators to combine numeric values. Now we're only going to scratch the surface here and talk about the most basic logical operators, which are the AND, OR, and NOT operators. And note that Boolean logic is actually not specific to JavaScript. This is all true for all programming. But anyway, let's now understand how these operators work and use an example to illustrate it. So here we have two Boolean variables that can either be true or false. So A is that Sarah has a driver's license, and B is that Sarah has good vision. So both of these are of course conditions that can be true or false, because Sarah could have no driver's license and she could have no good vision, right? And of course, on the other hand, she could also have a driver's license and could have good vision. Now, using the AND operator like A and B, we can combine these two Boolean variables like Sarah has a driver's license and good vision. Okay, but now what will be the result of this operation? Well, for that we use a so-called truth table, which looks something like this. Here we have the two possible values for each of the variables A and B, which gives us 4 possible combinations of results. And so then all we have to do is to plug in the value of our variables and get the result of the AND operation from this table. So what we can see from this table is that only if both A and B are true, the result of the operation will be true as well. And that makes sense, right? After all, it's called the AND operator. And so again, what the AND operator does is to return true only if both A and B are true. In all other situations, if either A or B are false, then A and B will also be false. And we can also generalize this to more operands, so to more than just two values. We could do A and B and C, and the result would be true only if all of them are true. And if one of them is false, then the result is immediately false as well. Now, I know that all of this might look a little bit confusing, but don't worry, we will have an example a little bit later in this lecture, and we will also use this in practice in the next one. And after some practice, you will internalize all of this, and you won't even need any truth tables. Now, moving on the other hand, we also have the OR operator, which kind of works in the opposite way. So with our current example, we could use the OR operator to determine whether Sarah has a driver's license or good vision. And just by thinking about this, we can already intuitively imagine that the OR operator will be true if just one of the variables is true. And in fact, a look at the truth table confirms exactly that. So unlike the AND operator and the OR operator, even if one of the variables is false, the outcome will still be true. Or in other words, if either A or B is true, then the OR operation becomes true as well. And that's why it's called the OR operator. And once more, if we have multiple variables, it's enough for one of them to be true to make the whole operation become true as well. Okay, I hope this makes sense. And once again, I can assure you that it will make sense once we start using this in practice. Anyway, we finally also have the NOT operator, which is a lot simpler because it doesn't combine multiple values. Instead, the NOT operator acts on only one Boolean value, and it basically just inverts it. So if A is true, it will become false, and if it's false, then not A will become true. Simple as that. And that's basically how these 3 most important logical operators work. But of course, the best way to understand it is to use a more practical example. So let's go again back to using the age, and this time we set it to 16. And then we have our 2 Boolean variables. The first one is age is greater or equal 20. And the second one is age is less than 30. So let's determine the value of each of them. So if age is 16, then age is greater or equal to 20 must be false, right? And of course it is. And age is less than 30 is true, because 16 obviously is less than 30, okay? So that's the baseline basically, and now we will start to combine these variables a and b using some logical operators. So the first exercise is the not operator, so not a. And we know right now that a is false, right? So the result of not a, as we just learned, is true, because all it does is to invert the logical value of the variable. Next one, we have a and b. And we already know that a is false and b is true. So I'm just putting these values here again to make it a bit easier to follow, okay? So we have basically false and true. So from a look at our truth table here at the right side, we can easily determine that the result of this must be false. And so that's exactly what we learned before. So when we have the AND operator, it's enough for one of the operands to be false to make the result of the operation also false. Now we have A or B, and so let's check out the truth table in this case. And so in this case, we actually get true. And so this shows that it is enough for one variable to be true for the whole expression to be true as well. Next up, let's check not A and B. And we already know that not A is true and B is true. And so this time, for the first time, we are combining multiple operators here. And yeah, we already know that true and true will of course be true as well. And now another one combining two operators, so A, or, and B. And just as a side note, the not operator actually has precedence over the or and operators. So basically the values are inverted first and only then they are combined using and or. So we know that A is false and B is true. So not B must be false, right? Then false or false is also false. And actually that's the only way in which the or operator can be false, if all of them are false, basically. So I hope that made sense to you. And so in the next lecture, we will actually use these operators in code. And then it will make even more sense to you. So by then, we probably won't even need the truth tables anymore, because it will become quite intuitive how both of these operators actually work. But anyway, let's now move on, and I see you in the next video. Let's now return to our code and learn how logical operators work in JavaScript. And let's actually use the Boolean variables from the last lecture. So the one about having a driver's license and having good vision. So we are going to create a variable for each of them. And the first one will be has driver's license. And let's start by setting it to true. And remember that this one was variable a. And then let's create has good vision. And also let's initialize it with true. So these were the two a and b variables that we used in the last lecture as an example. And so it's a good idea to use these here as well. Okay, but now let's get started with the and or operators. So let's log to the console of using the and operator on these two variables. So has driver's license, and now the and operator in JavaScript is this one. So with this we can combine two logical values. So has driver's license and has good vision. So let's see what the result will be. So this one is true, right? And this one is true as well. So the result of true and true should be true, right? So let's see. And yes, So that works. But now, of course, we will change one of them to false. So remember, the result of true and false will be false, because it's enough for one variable to be false for the result of the operation to be false. And so here we can now confirm that, and indeed, that is the result. But now let's see what it would look like with the OR operator. So I just copied this and paste it here. And now instead of AND, we use OR, and that looks like this. So again, true or false, what do you think it will be? Remember from the last lecture. And the result is true. So it's enough for one of the variables to be true for the whole operation to become true. So I hope that's nothing new at this point. And of course, finally, we can also use the NOT operator to basically invert one of the values. And the NOT operator in JavaScript is the exclamation mark. So NOT has driver's license will become, so it will change from true to false. All right. And now, since we know how all of this works, we can use these variables to take a decision. So let's say that we want to determine whether Sarah should drive or not. So let's create a new Boolean variable and use the others to determine that. So let's say should drive. And our model is that Sarah should drive if she has a driver's license and at the same time has good vision. Okay? And so, as I mentioned in the last lecture, we can now use these Boolean variables and this Boolean logic to model complex situations. And this one is actually pretty simple, but we will take it up a notch by the end of this lecture. So, remember, our model is that she has a driver's license and that she has good vision. Okay? And now we can use this variable to finally take the decision. So let's then use this Boolean variable here and say, if she should drive, then log to the console, Sarah is able to drive. And if not, just log someone else should drive. Okay, and actually, we can put the condition right here in the if condition. So this was just to show you a little bit the thought process. But as I mentioned earlier, we usually create the condition right here in the if statement. So give it a save, and now let's run it. And the result is someone else should drive. So that is because has good vision is false. And so our condition of has driver's license and has good vision is not true, because it's only true in case that both of them are true, as you already know by now. So this one is false right now, and so therefore the else block will be executed. But of course we can change it once more. And so right now, both of them are true. So has driver's license, true, and has good vision, true. So true and true is true, and so Sarah is able to drive. Let's check that, and indeed. Great. And with this one working now perfectly, let's take it to the next level and add another Boolean variable here. So let's now also add is tired. And let's set it to true as well. So we can say that this is our variable C. So to use more than two variables with, for example, the AND operator, let's just go ahead and copy this one. So if you want to say has driver's license or has good vision or is tired, all we have to do is to add another OR operator here, just like you would add another plus or another minus operator. And the result of this should, of course, be true because, well, all of them are true. And indeed, it is. And if we set them all to end, then it is also true because all of them are true. If we set this one to false, then as you can guess, the result will be false. And that is because, as I explained in the last lecture, it's enough for one of the operands to be false to make the whole AND operation false as well. Okay, but let it set back to true. And now we can use this to improve our decision making whether Sarah should drive or not. So with this third variable now, we want Sarah to be able to drive if she has a driver's license, if she has good vision, and if she is not tired, right? So let's now translate that into a condition. And I will just copy this one and then comment all of it out using command or control slash, just like many times before. And now we will improve this one. So this one, of course, is the same, that she needs to have a driver's license and good vision. But now additionally, we want her to be not tired. So right now she is tired, it's true. And that's, of course, not good for driving. So we want the opposite of being tired. And so, therefore, we need to invert it. So do you remember how that works? All we need to do is to use the not operator. So not is tired. All right. So let's read this again. Sarah is able to drive if she has a driver's license. So if this one is true, if she has good vision. So if this one is true, and if she is not tired. So if all of this is true here. So only in this condition, Sarah is able to drive. Now, how is this part here true? Well, it's true when is tired is false, right? So what do you think will happen in this situation right now? Well, let's test and then analyze. So we get the result, someone else should drive. So why is that? Well, this one is true, this one is true, as we see up here, and then is tired is also true. However, not is tired is false. So this part here is false. And so true and false is, of course, false. And so therefore we get the else block, someone else should drive. Now to fix this, we need to change is tired to false. All right. And so right now is tired is false, and therefore not is tired will become true. And then we have true and true and true. And then in this situation, Sarah will be able to drive. Yes, indeed, it works now. So as you see, with these three Boolean operators, we can model all kinds of complex decisions like this one. Now, I know that this was probably a bit confusing, but please don't worry too much because it's all very confusing for everyone when they first learn how to program. Okay, just take some time after this video and analyze again exactly what happens here, maybe also together with the last video, to really make sure that you understand what is going on here. But of course, the best way to retain any knowledge is by practicing and reinforcing it. And so let's do that now in the next coding challenge. Okay, hopefully you managed to complete at least point 1 and point 2. And so let's start by solving these two. So number 1 is calculating the average of both teams. So let's create one variable for each. So score Dolphins. And so to calculate the average, we simply add up all the 3 scores and then divide it by 3. So we already did something similar before. So that's 96 plus 108 plus 89, and then divided by 3. And we need these parentheses so that these plus operations are executed first, because the grouping, so the parentheses, have a higher precedence. Okay, score koalas is 88 plus 91 plus 110. And again divided by 3. And now let's quickly log both to the console here. Score dolphins and score koalas. Okay, so they're pretty close, but the dolphins have a little bit higher of an average. And so that's what we're working on in point 2, where we're going to compare the average of both teams. So we are going to use an if statement, or if else probably. So score dolphins, if it's greater than score koalas, then log to the console dolphins win the trophy. And we can get fancy here with some emoji. Let's see if we got one. Ah, that's the one I'm looking for. But of course, once more, you don't need to worry about this part. Let's just copy this for the next one. So else, and actually we are going to use an else if because of the draw. But let's talk about that one later. So if the score of the koalas is greater than score dolphins, then we're going to print the opposite, so that koalas win the trophy. And finally, else if score dolphins is equal to score koalas, then we can simply say that no one wins the trophy. Or actually both win the trophy. Okay, so let's test that. And indeed, we get that the dolphins win the trophy. And that's because, as we know, this value is greater. And so actually this first condition here turns out to be true right away. And so this block of code here gets executed. Now let's just quickly increase the score of the koalas here. Let's say 100, just to see if the second part also works. And indeed, now the koalas win the trophy. Okay, but let's put it back here. And here you could have actually done it in another way. So you could have done score dolphins less than score koalas. So basically write the same as here, but instead of the greater, you would have used the less than. So that's the exact same thing, and both are equally valid. Then here in the last part, actually we wouldn't even have needed this part, so that the score of dolphins is equal to score of koalas, because that's actually the only scenario that's left given these previous two conditions. So basically, if none of these here were true, really the only thing possible would be that they had the same score. And so a simple else block would have been enough here. But anyway, this works just fine too. And so again, what matters is that you made it work, even if you did some things differently. For example, you could have stored the conditions in separate Boolean variables, or you could have structured the if-else statement in some different way. But if you got the same result that we just saw here, then congratulations. That's a great work. Well done, really. So maybe you even made it to bonus number 1 and 2. And so let me solve them here now as well. So let's start by calculating the average. So this is going to be bonus 1. And yeah, let's copy this one too. Let's copy this one. Let's copy this one. So I should have done it all in one go so that we can now comment out this first part. So for test number 1, this should be 97. Then the second one should be 112 and 101. And for the koalas, we have 109, 95, and 123. Let's just quickly test. And so right now the koalas win the trophy. So for now, everything works the same. But now we need to include this important condition here, which is that with this rule, a team only wins if it has a higher score than the other team, which we already have, and at the same time a score of at least 100 points. Okay, easy enough. So in this case, the Dolphins win. Okay, but now we also need to ensure that the Dolphins have a score higher or equal 100. So let's just say that. So Dolphins need to have a higher score than Koalas, and score Dolphins needs to be greater or equal 100. And that's it. That's all we need for this requirement. And then the same thing here. So this is the scenario where the Koalas win. So for the Koalas to win, they need to have a higher score than the Dolphins, and at the same time, they need to have at least 100 points. So just like before, greater or equal 100. And so once more, we used a logical operator here to model this situation, essentially. Okay, and actually, I think with this, we implemented this bonus number 1. So let's try that again. And right now, of course, it still works because both have a score higher than 100. But let's change that now here, according to test data 2 to 106. So 106. And now they both win the trophy. So let's actually decrease all of these points like by 20. So let's make it 81 and 86. So the average should still be the same now. Yeah, but they're both below 100 now. And so this brings us to bonus number 2 that says that the minimum score should also apply to a draw. So a draw only happens when both teams have the same score and both a score greater or equal 100 points. Okay, and otherwise no team wins the trophy. So that's important too. So let's translate that. So to be a draw, the score needs to be the same, which we already have, and the score of Dolphins needs to be greater or equal 100, and the score of Koalas needs to be greater or equal 100. Okay, and else, well, then we can say that no one wins the trophy. And let's just add some sad emoji here. Okay, let's try that. And now we get that no one wins the trophy. Okay. So that's because their scores are now below 100. And so we actually entered this last case here. But if we go back to the averages that we had before, so 106 and 101, let's see. And now both win the trophy because they have the same amount of points and they both have a number of points above 100. And so that's exactly what we have here. So same points, Dolphins have over or at least 100 points, and Koalas have at least 100 points. And so in this case, both win the trophy. Finally, let's also test the scenario in which both have below, but the Dolphins have a little bit more. Let's put this one here at 80. And so now we see that the Dolphins have 96 points, and the Koalas have 84, but still no one wins the trophy. And that's because the Dolphins have more than the Koalas, so this part of the requirement is true, but they do not have over 100. So this part here is false, okay? And so true, this first part here is true, and the second part is false. And true and false gives false. And so then all of these are skipped because they're also obviously false. And so we go straight to this last block. And so no one wins the trophy, which is exactly what we were expecting as a result here. Okay. Now, if you didn't manage to do this here, again, don't worry, because I know that this is a little bit complicated already. And so in case you managed to successfully complete this challenge, then a huge congratulations to you. Well done. But if for some reason you were not able to complete the challenge, then don't worry all too much about it. You can always go back to the lectures where we first learned about these topics, and you can, of course, after this video, also review the code a little bit more carefully to make sure 100% that you understand, especially this last example that we just worked on. Okay? But anyway, great job in completing this challenge, and now I see you in the next video. Let's learn about the switch statement, which is an alternative way of writing a complicated if-else statement when all we want to do is to compare one value to multiple different options, basically. So in this example, let's say we have a weekday variable, and for each day there is a different activity. So basically we're going to map one activity to each day. So let's say day, and I'm setting it here to Monday. Now maybe you're wondering why I'm basically hard coding all these variables and how this would work in the real world. Well, in a real application that's used by users in the browser, usually most of the data comes from user input. And so then we wouldn't be hard coding all of this stuff. Okay? But right now, well, we are just learning how to code. And so it's absolutely no problem at all to just hard code all of these values here. Okay? Now, anyway, going back to our example here, let's now essentially map one activity to each day. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And for that, we could use an if-else statement with multiple else-if blocks, but we can also use the easier to use switch statement. So let me just write how that works, and then I'm going to explain it in a bit more detail. So what we're switching is basically the day. So this is what we're going to compare to multiple options. Then we need the curly braces to define a block, and then we can define cases. So let's say case Monday. Then this colon, and notice how it's a colon and not a semicolon like this. Then another indentation, and then here comes the code that we want to do. So as always, we log something to the console. And once more, in a real-world app, we will of course not be logging stuff to the console all the time. This is once more just so that we can learn how all this different stuff works. So let's say on Monday I plan my course structure. And here we can actually execute multiple lines of code. And we don't need curly braces for that. So after the case and the colon, all the lines are then executed. Okay, and the syntax of this switch statement is actually a little bit unusual. So it's unlike anything else in JavaScript, but well, that's just how it is implemented, I guess. So anyway, we will execute two console.logs here. So the second one is go to coding meetup. Okay, so basically what this will do is it will compare day to Monday here in a strict equality way. So this here is basically writing day equal Monday. And if this is true, then this code here will be executed. Okay? Now, after this, we actually need this break statement. And you will see why in a second. And now let's add the next case here. So case Tuesday. So basically we're going to do one for each day of the week here. So let's say prepare theory videos and then another break. And I wish that preparing theory videos would only take one day, but it doesn't. Okay, so Wednesday is the next one. And actually we can do a nice little trick, which is to run the same code for two different values. So all we have to do is specify this case, and then we can specify another case right after it. So let's say day here. And so whatever we write here will then be executed for both Wednesday and Thursday. So without needing any logical operators as we would need with an if-else statement. And actually, we're going to translate this into an if-else statement after we're done here so that we can analyze the difference. So let's say Wednesday and Thursday, I write code examples. On Friday, I record videos. And here's a small bug. So it's a colon, as I was saying you. And then let's do Saturday. And also the same for Sunday. So console.log, and then here, enjoy the weekend. Okay. And then, oh, I actually am forgetting the breaks here. So break. And I will show you in a second what happens without the break. But anyway, to finish, we can also set a default. And so the default is going to be executed if all the other cases fail. So default, just like this. And then here we can simply say console.log, not a valid day. So basically we're using this for an invalid weekdays. It's basically like an else block at the end of a long if-else statement. Okay, so let's now check out the result. And indeed, we get these two logs here from here. So from line 379 and 380, which are exactly these two lines of code. Then if I change it to, let's say, Wednesday, like that, we get write code example. And on Thursday, it should yield the same result because, yeah, we did this here for these 2 days. Now I guess I wrote something wrong. And actually it's here, Thursday, right? But so you saw that actually, since this option here was nowhere to be found, we actually got to the default block, which is then not a valid day. But now we should get the right code examples. Now without the break here, and let me comment it out just for demonstration. If we put this back to Monday, then let's see what happens if we load. And so now we get 3 outputs. We get this one, and this one, and this one. So that's the one immediately after Tuesday. And this happens because without the break, the code simply continues executing. And it stops here because here we have the break. But if I remove this break as well, then it would continue down this structure. And so after each block here, we need to tell it to stop, essentially. And so now it's fixed and it works just fine. Okay, great. That's how the switch statement works. And remember that this actually does a strict comparison. So it does it like this. Here it does, if the day is equal to Monday, then execute this. If the day is equal to Tuesday, execute this, and so on and so forth. So this was really designed for equality and not for like comparing stuff. It is technically possible to do that with some workarounds, but that's not the goal of the switch statement. Now, just as a fun exercise and to get a better idea of how this actually works and also how the if-else statement works, I want to challenge you to write this same logic, but this time as an if-else statement, okay? And to do that, you will have to use a logical operator to translate the case of the Wednesday and Thursday case. So think about what happens. So basically, write code examples should be executed if the day is Wednesday or Thursday, right? So whenever the day is one of these two. So it's impossible to be Wednesday and Thursday because, well, 2 days cannot occur at the same time. So keep that in mind. And yeah, pause the video here and really try to do this one on your own. Okay, did you do it? Well, let me just quickly show you how it's done. So remember that we're using strict comparison, so the triple equals. So if it's Monday, then do this, and I will, after finishing the structure, I will just go ahead and copy the console logs from up there. Then we need an else if. For the case it's Tuesday, then we need another else if in case the day is Wednesday, or if the day is Thursday. And again the same error. And you see that we're writing quite a lot of repetitive code, especially always the day and then the triple equals. So, and that's what the switch statement kind of tries to avoid. So else if, and then if the day is equal to Friday, do this. Else if the day is equal to Saturday, or the day is equal to Sunday. And finally, also the else block in case that we have an invalid day. So let's grab these here. And note that in this case, we of course don't need the break, because JavaScript will only execute one of these blocks. So Friday and now Tuesday, and finally Monday, these two activities. Okay, give it a save, and now I'm gonna reload here. And so now we should expect the same result here, but twice. Once coming from the switch statement, and once from this big if-else block. Yeah, and indeed, it works just the same. Let's just try another one. Say Friday, just to make sure. And yeah, the result is the same. And so this logic here does basically exactly the same as this. We simply wrote it with a different syntax. Okay, so with the switch statement, we have to write a little bit more code, but in my opinion, it's also a lot more readable, which means that this one is easier to understand if you just read the code. Here we have a lot of this repetitive code and all these curly braces, and it just looks a little bit weirder. At least that's my opinion, but of course everyone is different. Now the switch statement is actually becoming less and less used, but you should still know about it, because there's definitely still a place for it sometimes. And actually in this example, for instance, I would actually prefer to use the switch. Okay, but again, that's down to your personal preference, and it's good that you start basically developing your own coding style into what you like the most. Now that we're getting more comfortable with JavaScript, it's time to learn about a more theoretical concept, and that's the difference between statements and expressions. And this is going to be just a very high-level overview, just so that the future lectures make more sense. So essentially, an expression is a piece of code that produces a value. For example, 3 plus 4 is an expression, because this is going to produce a value. Okay, so I don't even mean the entire line of code. What I mean is really just this 3 plus 4. This is an expression, okay? And again, because it does produce a value. The same goes, for example, for just any number. This, for example, is an expression too, even though it's just a simple value. But it's still also an expression, because again, this itself will produce a value in JavaScript. Or we can do this. So true and false and not false. So all of this here is an expression, right? Because this will in the end produce some Boolean value. Now, on the other hand, we have statements. And a statement is like a bigger piece of code that is executed and which does not produce a value on itself. And we can compare this with normal spoken language. And so in this example, a declaration is like a complete sentence, and expressions are like the words that make up the sentences. Now, basically, we write our whole programs as a sequence of actions, and these actions are statements. So let's take as an example the if-else statement. So let's say if 23 is greater than 10, then, well, just do something. So create a string called 23 is bigger. The code itself doesn't really matter here. So this if-else statement is in fact a statement. And so that's the reason why I have called it the if-else statement all the time. And the same is true for the switch statement. So this statement here doesn't really produce a value, does it? All it does is, in this case, it simply declares this variable called str. But that's it. It performs some actions, in this case declaring this variable, but it doesn't produce a value. And so in that, it's different from, for example, having this here. Okay? Now the string itself, again, is an expression. So this is probably a bit confusing, but that's not a problem, okay? My goal here is not that you understand the exact rules of what an expression is and what a statement is, because in fact, it's all a bit fuzzy. So my main goal with this lecture is really that you know that statements and expressions exist, and that expressions produce values, and that statements are like full sentences that translate our actions. So the actions that we want the program to perform, okay? So really, that's all you need to know and all you need to basically memorize from this video. We don't need to go into all the details. So there's no need to start asking a bunch of questions about this in the Q&A section, all right? So this will all make even more sense as we move on. So I said that this string here is itself an expression, and then this whole line of code is a statement, because this again does not produce a value. And so basically, whenever something ends with a semicolon, that's then a statement. It's like a complete sentence, okay? Now this difference between expressions and statements is important to know because JavaScript expects statements and expressions in different places. For example, in a template literal, we can only insert expressions, but not statements. So let me just very quickly demonstrate that to you. So we can say, and then our placeholder here, basically. And so in here, we need to put an expression. So something that produces a value, which can then be put into the string that we're building here using the template literal. So let's say, just to do some calculations here, so 2037 minus 1991 years old. So again, this is an expression here. And so this one will work. However, we cannot do this. For example, we could not insert this if statement in here. That wouldn't make any sense at all. Okay, let's try that. And so we actually get right away unexpected token if. And that's because JavaScript knows that this is a statement and statements don't make sense where JavaScript expects an expression. Now, if we had a variable, for example, then if we used that here, then this would actually also be an expression because this variable will essentially just be replaced with this string. And so this produces a value. And so, of course, this is completely acceptable. Okay. And that's actually all I had to show you in this video. Again, my goal was really just to make sure that you kind of understand the difference between expressions and declarations so that moving forward, we are really both on the same page here. So we already saw two ways of writing conditionals: the regular if-else statement and the switch statement. But there is another one, and that's the conditional operator. And this one is actually really nice. So let's check it out. So the conditional operator allows us to write something similar to an if-else statement, but all in one line. So let's again start by defining an age variable. And this time I'm setting it to 23. And now let's write age greater or equal 18. So this is here our test to check whether the age is at least 18. So basically if the person is of full age. And then after this condition, we use the question mark. And then here we write essentially our if block. So that's the code that we want to be executed in case that this condition here is true. So let's say console.log, I like to drink wine. Let's again add a nice emoji here. So basically, if the person is of full age, they are allowed to drink wine, okay? And in this if block, so to say, we can only really have essentially one line of code. So only one thing can be done if this condition is true. Then we also need basically a mandatory else block, and that goes after this colon. And so let's just copy this code and say, I like to drink water. Okay, and that's actually it. So let's check the result and then analyze this a bit more. So in fact, what gets logged to the console is, I like to drink wine. And that's because the age is 23, and so this condition is true, right? And this means that this code here is going to be executed and this one is not. So the second part here, which is essentially the else part. Now, if we were 15, then of course, the second part is executed. Okay, so that's essentially writing an if-else statement all in one line. But instead of using a statement, we use this conditional operator. And the conditional operator is also called the ternary operator because it has three parts, unlike other operators. For example, the plus operator has only two parts. For example, 1 plus 2. But this one has three parts. So the condition, then the if part, and then the else part. Okay? Now, the conditional operator is in fact an operator, just as the name says. And remember that an operator always produces a value. So in other words, an operator is an expression, right? So what this means is that if we have a value, we can then assign that value to a variable. And so with this, we can make the ternary operator really useful to basically conditionally declare variables. So what we did here is not so much used, indeed. Instead, we do it more like this. So we would still test for this condition, let's say. So checking if the person is of full age. And if that's true, then all we want is essentially to return this. And if not, we only want this. Okay? And so again, this whole operator here is now an expression. And an expression produces a value. And so now we can go ahead and store that value into a variable. So let's call that drink. And then we can log this drink to the console. And let's comment out this part here and check. And indeed, we get wine as we declared up here. Great. So drink is now really defined conditionally based on this condition and all in one simple line. So without the conditional operator, we would have to use an if-else statement. And with that, this wouldn't be so easy. Remember, when we want to declare a variable inside of an if or an else block, we need to first declare that variable outside. So let's actually do that. So simply call it drink2. And then we would say if the age is at least 18, then drink2 is going to be wine. Let's just grab that here. Or else drink2 is going to be this water here. Okay, and again, we need to define the drink2 variable outside of the if and the else blocks, because any variable that we define inside of a block is not available outside. So we declare the variable here and then reassign it inside of the blocks. So just to make sure it worked, let's log this one here as well. But we really just did this for the sake of comparison. Okay, just so you can see the tremendous difference that the ternary operator introduces here in our code. So if you ask me, this one here is a lot easier to understand and a lot easier to write, right? So just changing this to something else here. And yeah, in both cases, we get a water back. So using the ternary operator, we were really able to transform this big block of code all into one small operation like this. And this is going to be useful in so many cases. And we will really take advantage of this throughout the rest of the entire course. And now we can take it even further. Because since the ternary operator is really an expression, we can now use it, for example, in a template literal. So unlike a normal if-else statement, like we tried and failed in the last lecture, remember? So that was here, where I tried to insert this if statement here, and of course it didn't work. But using the ternary operator, which produces a value, we can actually have conditionals inside of a template literal. So let's simply try that. And so I can now say, I like to drink, and then based on the age, I can say if I like to drink wine or water. So here in this placeholder, remember, I can put any expression that I want. And this here is an expression, again, because it produces a value. So I grab it from here, paste it here, and that's it. The template literal will now use whatever result we get from this operator. So that's either going to be wine or water, and then it assembles that result into the final string. So let's check. And indeed, once more, the conditional operator works just fine. And with our age back to 23, then we get, I like to drink wine. Great. So I hope that this makes sense. I know that especially this part here can be a little bit confusing for beginners. So take a minute to really understand what happens here. And always keep in mind the concept of operator and of expression, which is something that produces a value. And thanks to that, we can then put that value here in this placeholder in the template literal. All right. Now to finish, I just wanted to mention that the ternary operator is not thought as a replacement of if-else statements. Okay, we still need if-else all the time. For example, when we have bigger blocks of code that we need to execute based on a condition. In that case, the ternary operator is not going to work. But the ternary operator is perfect when we just need to take a quick decision, for example, like this one. And that's especially true in places where JavaScript really expects an expression, just like here in this template literal. So here we could not use an if-else statement, and so the ternary operator really comes to our rescue here. So I think you can understand that this one is really, really important, so make sure that you absolutely understand how it works. And once you do understand, then let's move on to the final lecture of this section, which is yet another coding challenge for you to see if you did actually understand how the conditional or ternary operator works. Okay, so I hope you successfully did that. And so let's try to solve it now together. Or actually, let me show you my solution so that you can see how it compares with yours. And as always, you can also find my solution in the final folder in the GitHub repository. Okay. Now, actually, let's start with the bill variable, which I'm going to set to 275, which is here the first test value. And now the tip, and let's calculate it using the ternary operator. So let's implement this rule, which is if the value is between 50 and 300, then the tip should be 15% of the bill value. So that means that bill must be less or equal 300, and at the same time, bill must be greater or equal than 50, right? And again, that's what it means for the bill value to be between 300 and 50. It's going to be less or equal 300 and at the same time greater or equal than 50. So 40, for example, is of course less than 300, but it's also less than 50. And so this part here will then be false. And so this entire expression here, which is then true and false, will be false as well, right? So in this case, the tip here will be the bill value times 15%, which, as I explained here, all we need to do is to multiply it by 15 divided by 100. So that's 0.15. And else, it's 20%. So bill times 0.2. Give it a save, and that's actually it. So that's number 1. And now as number 2, let's log this string to the console as is requested here in number 2. So let's actually grab this template here. So then we just have to replace the values. And so since we're building a string, we are again relying on the template literal. So here we're going to put the bill value. Here we're going to put the tip. And we're missing the curly braces. And here the total value is going to be the bill plus the tip. So we can, as you already know, write an expression here using this operator, so the plus operator. And that's actually it. So let's try it. And with this bill value, the output should actually be exactly like it's written up there. And it is. So 275, the tip is 41.25, so just like here. And the total value is 316.25. Great. And just to understand this one, so this condition a little bit better, let's just take this one and paste it here into the console. And so we see that this one is true. And of course, that's because 275 is less than 300 and more than 50. So it is between this range. And therefore, this part of the ternary operator here will be executed and become the result of this operator, essentially, right? So the result of this operator will be bill times 0.15, and that's the value that will then be assigned to the tip variable, okay? Now let's try another one. So 40, and now the tip was 8. Let's try this one here again, and now the condition is false. So remember that here in the console, we have access to all the variables that we have declared here. So if I write bill now, you will see that it's actually 40. So bill is obviously below 300, but it's also below 50. So this part is false, and true and false gives false. And so in this case, the value that's going to be assigned to tip is 40 times 0.2. And that's exactly 8. So it's what we see here. Okay, and now just for the sake of completion, let's do the last one as well. And Yeah, this should have worked as well, because now this one is false again. And that's because this time 430 is above 300. And so 86 should be 430 times 0.2. Let's quickly check that. 0.2. And that's right. That's the 86 that we have up here. Great. So hopefully you did this. And once more, if you did it a little bit differently, that's not a problem at all. I just hope that you made it work. Okay? And actually, this concludes the coding part of this section. There's just one more lecture left, which is going to be a deeper dive into JavaScript versions, especially into ES5 and ES6. So it's going to be an interesting one. And yeah, I'm waiting for you there. Now that you're familiar with the fundamentals of the JavaScript language, we need to talk about JavaScript releases or versions before moving on. And we briefly talked about this in the intro video, but now let's go into more depth because it's really important to know about how JavaScript releases work and how we can use them. It's important for your work as a web developer and also because you will see these topics coming up in the developer community all the time. And so you want to be able to understand what's going on. And the best way to start understanding JavaScript versions is by looking at the history of JavaScript. So let's do that. And let's start at the beginning of the internet itself. So quickly after the internet was invented and the first web browsers were developed, developers wanted to start making websites more interactive. In other words, they needed a programming language for the browser. So in 1995, the Netscape Navigator, which by the time was the dominant browser, hired a guy named Brendan Eich to create the very first version of JavaScript in just 10 days. It was called Mocha, so not JavaScript yet, but it already had many of the fundamental features that modern JavaScript has today. So that's very impressive that he basically created this first version in really just 10 days. Then in 1996, Mocha was renamed to LiveScript, which was then again renamed to JavaScript for one simple reason: to attract developers from the hottest language at the time, which was Java. So the Java in JavaScript was really just for marketing reasons, because the language itself has basically nothing to do with Java. Now, some beginners think that this is the case, but actually no. JavaScript and Java are two completely different languages. Also in 1996, Microsoft launched the Internet Explorer, which basically copied JavaScript from Netscape. But they called it JScript for legal reasons because, well, you actually cannot just go around and copy other people's programming languages. Now, what this means is that we now had two very similar but competing languages, which of course is never a good idea in the long run. And so, with the internet growing like crazy around this time, people realized they needed to standardize JavaScript. So the language was submitted to an independent standard organization called ECMA, which in 1997 released ECMAScript 1 or ES1. This was the very first official standard for the JavaScript language. And with this, every browser could now implement the same standard JavaScript. In the real world, we usually use the term ECMAScript to refer to the standard, while JavaScript is used when we talk about the language in practice, as it's implemented in browsers. Now, fast forward to 2009, after a lot of complications and disagreements about where the language should be headed, ES5 was released with a lot of great new features. And then finally, another 6 years later, the much-awaited new version ES6 was launched in June 2015. And this was the single biggest update to the language ever. So it contained a ton of new exciting features, which we will explore throughout this entire course. This was and still is a really big deal for JavaScript and for the whole web developer community. Now, you will also see ES6 being called ES 2015, which is actually the official name, but most people just call it ES6. And so that's what I'm going to do here as well. And actually the reason for ES6 being called ES 2015 officially is that in 2015, ECMAScript changed to an annual release cycle. So right now, there's going to be a new release every single year. The reason for that is that they prefer to just add a small number of new features per year instead of shipping a huge new version every couple of years like it happened with ES6. And so this way, it's going to be much easier for everyone to keep up to date. And so according to this new annual release cycle, in 2016, ES 2016 or ES7 was released, ES 2017 in 2017, and like this, it will continue until the end of time, or something like that. Now, there is one particularity about JavaScript releases which is pretty unique for any programming language, and that is backwards compatibility all the way to ES1. So what does that actually mean? Well, basically it means that if you were to take some JavaScript code written back in 1997 and put it in a modern browser with a modern JavaScript engine today, it would still work just the same. So again, the JavaScript engine that's in our browsers today is able to understand old code written 25 years ago without having to rely on version numbers or anything like that. It just works. And it works this way because of the fundamental principle that's baked into the JavaScript language and its development, which is to not break the web. This means that there is almost never anything removed from the language, but only added in new versions. And actually, we cannot really call them new versions even, because they do not contain breaking changes like when other languages move to a new version. Instead, new versions are always just incremental updates which add new stuff. And so I like to call them releases and not versions. The ECMAScript committee who works on updating the language does all this so that old websites basically keep working forever. Just imagine they removed some important feature that made a website from 2008 work just fine. If you then wanted to visit that page, it would be broken. And that's why we, fortunately, have the don't break the web principle. Now, of course, this comes with problems, because there are tons of old bugs and weird things in the language. Remember that Brendan Eich made the very first version in just 10 days. And no one back then could even imagine what JavaScript would be used for one day. The initial goal of JavaScript was just to add some simple dynamics to pages, not to write whole web applications in the browser like we do today. But anyway, these bugs and weird quirks in the language have been giving the language a bad reputation among many programmers, who can't really take JavaScript serious because of this. But here's the thing. We can actually go around many of this weird stuff by simply learning the modern JavaScript that matters today and just ignore most of the old weird stuff. And so that's exactly what we're going to do in this course. So next time your friends start hating on JavaScript, and believe me, this actually happens, then just tell them about the amazing things that you can build with it. Okay, but now there is one more thing that we need to talk about here, and that is forwards compatibility. So what do you think would happen if we took this totally made up code from the year 2089 and tried to run it in today's browsers? Well, you're probably right, it would not work at all. There would be errors left and right, and nothing would work. That's why we say that JavaScript is not forwards compatible. Basically because current browsers do not understand code from the future. And this actually brings us to our next topic, which is how can we use modern JavaScript today? Because browsers that users are using might be old, and there is no forwards compatibility, right? So to answer the question how we can use modern JavaScript today, we need to consider two distinct scenarios: development and production. So the development phase is simply when you're building the site or application on your computer. To ensure you can use the latest JavaScript features in this phase, all you have to do is to use the most up-to-date version of the Google Chrome browser. This will then ensure that all the features I show you in this course will work for you as well. The second scenario is production, which is when your web application is finished, you deploy it on the internet, and it's then running in your user's browsers. And this is where problems might appear, because this is the part that we actually can't control. We cannot control which browser the user uses, and we also can't assume that all our users always use the latest browsers, right? Now, the solution to this problem is to basically convert these modern JavaScript versions back to ES5 using a process called transpiling and also polyfilling. We will use a tool called Babel later in the course to transpile our code, but for now, during the course, we won't need that. Again, because you're using the most up-to-date browser during development. Transpiling back to ES5 is only necessary after your app is developed and you want to ship it to your users. Alright, so now let's take a look at how different JavaScript releases can be used today. So first off, ES5 is of course fully supported in all browsers today, all the way down to Internet Explorer 9 from 2011. So we can assume that ES5 is safe to be used at this point, which is the reason why we use it as a target for transpiling. Now about the newer releases ES6, ES7 and all the way to ES 2020 as of mid-2020, they are actually quite well supported already in all modern browsers. And we usually call all the current versions together ES6 Plus. So right now that's from ES6 to ES 2020, and basically all together they are the modern JavaScript. Now it's in this modern JavaScript, so in this ES6 Plus, where transpiling comes in, as I mentioned earlier. Again, because it's not safe to assume that all our users are using these modern browsers, and we don't want to break our app for them, right? And by the way, if you want to stay up to date with what features are currently supported in which browser, you can check out the ES6 compatibility table. It's really interesting. The link is actually on my resources page on jonas.io. Next, there are also the future releases of the language, like ES 2021, ES 2022, and so on. And these future releases together are many times called ES Next. Now, why is this even relevant? Well, because most browsers actually start implementing new features even before they enter the official ECMAScript specification. That's possible because as new features are proposed, they have to go through 4 stages, starting with stage 1, where they are first submitted, all the way to stage 4, at which point they enter the language officially. But when a feature is at stage 3, browsers can be pretty sure it will eventually pass to stage 4, and so they're going to start implementing that feature while still in stage 3. And there is a lot more to be said about this, and actually I find this really fascinating, but I'm going to stop here. You can find tons of information about this online if you want to learn more. And a great place to start is actually, once more, this compatibility table that's up here on the slide. But anyway, as these new features start coming out, I will simply add new videos about them to the course in order to keep it updated. With the annual release cycle, this is now way easier to do, because there will be no drastic changes to the language like ES6 was. Okay, and now to finish, let's quickly talk about how versions, or releases, are taught in this course. So, as I said earlier, I will teach you modern JavaScript right from the beginning of the course. Now, I used to teach this course starting with ES5 and then moving to ES6 in the middle of the course. But now, after a couple of years, it was time to fully move to modern JavaScript. However, it's also super important to learn how some things used to be done before we had this fancy modern JavaScript. For example, in this section, I already showed you the modern const and let for variable declarations, but also how we used to use var before. And there will be many more examples like this. But why bother with ES5 at all, you might ask? Well, here is why. First, you will better understand how some features in JavaScript actually work behind the scenes. For example, ES6 classes, which hide all the implementation details of object-oriented programming in JavaScript. Also, many tutorials and example code that you will find online are still written in ES5 today. Plus, as a developer in many jobs, you will actually have to work on older code bases. And it's totally possible that that code base might still contain a lot of ES5 code. Okay, so I hope that made sense. And that's it for this lecture and for this section. So see you in the next one.